It's assist. It's working. I don't know why YouTube has to like play with stats. I don't really care though, but I kind of like, I don't know. I stream the same way for well, first up, I don't know. It's like this, whatever. It says it has 2 views, whatever. From the day before yesterday. Go to the video though. It says 8 right here. 8. All the videos, they're like this. The numbers make no sense. Only on the newer ones, though. And I know that something's off. Because I did the same thing the last however many days. Here's my traffic. And then I talk about a certain topic last night. And when I talk about a certain topic last night, something happens in the views. You see how it dips right here? I mean, it's like pretty steady. Then last night, certain topics, I guess. I don't know. It seems like I could predictably drop the views somehow. There's no algorithm. They got people assigned to watch the streams, and then they have a switchboard. There is no algorithm. So I don't know. Twitch was easier to catch if they were like messing with stuff. But now I know YouTube's playing games too. I don't care though, it's whatever. I'm not gonna make money from YouTube. I'm gonna make money from after I meet the standard. ECMA standard, whatever. And I finish up on JavaScript Engine. So I don't care about YouTube views. I just think it's odd. And then I hate these smiley faces. It seems unprofessional and condescending. And like, what even? It says like 36 views. When I go to the video, it says 48. Right? I think somewhere in there. Certain topics YouTube doesn't like. So at least I know what not to say. And if I do want to like test the traffic, whatever, I kind of have a way to like, I don't know. It's like my decision. I can do good or I can do bad. But it's not organic. There's something going on YouTube. It's a bunch of shit. Perception is a game. And YouTube, I don't know, whatever. They're better at playing the game than other companies. I'll give them that. Anyways, I'm gonna get to working on my JavaScript engine. This is ECMA 262 JavaScript standard, 200 pages, 2009 standard. On the right hand side, I guess. I open them backwards. This one is this standard for JavaScript. It's only 241 pages. So I'm going to meet this standard first. It would suck to work at YouTube and watch people all day and pick. That'd be a horrible job. Be a difficult job. And this is a 2024 ECMA standard, whatever, same standard, 2024. This one's from 2009. I wonder if they like assign specific people to certain channels, or if it just kind of goes to a room and they like sift through people. This 2024 standard is 804 pages, much larger. So I'm going to meet the ECMA to 2009 standard first, because it's smaller and easier to set up. I'm going to get these mechanisms in place, and then I'm going to go through and apply everything from here to the 2024 standard. The 2024 standard is a modern as, I guess, chatbot, or I don't know, Google, all of them, they'll say they're modern software, whatever. The modern standard, 2024, it has the word leak in the standard. Because that's the modern thing to do, is you just say things will leak memory because people don't know what they're doing. And that happens. That's modern. The 2009 standard doesn't have the word leak. So either 2009 standard, JavaScript standard, has leaks in it, but they didn't know, and then they addressed it in 2024, maybe between there, because there's standards between, or not. I didn't look into it yet. At some point I will. I'm going to go through every single page. So if I look for the word leak, and then I hit next, whatever, it doesn't show up in the 2009 standard. But if I go over to the 2024 standard and type in the word leak, it shows up 2 times in the 2024 standard the word leak. The first time, they say that JavaScript engines may leak resources. And on the second time, they say the word leak. By they, I mean the ECMA standard people who wrote it. The second time, they address the leaks by saying, here's a couple mechanisms that you can use in your engine when you follow the standard. But those mechanisms are from ages ago. So you would think that when writing this 2024 standard, this modern JavaScript standard, the year's 2025, we don't live in the 1960s, the 2000s. This is 2025. But when it comes to programming standards and quality of quality control and the customer, that means nothing. It's all about convenience and high level programming and blaming it on someone else because it's so complicated that it's not their problem. Whose problem? It's no one's problem. It's just the way it is in 2025 because it's modern times. So there's mechanisms, as it says, the word leak. I'll click to it. So in 2024 standard, it addresses leaks because the mechanisms that make up the standard are broken. That's why I want to do the 2009 standard. Either they forgot the word leak, or it means that the mechanisms in place are solid. So I don't know till I get to it. But at least if this doesn't have leaks in logic, I'll feel more comfortable doing it. And then when I get to the standard, the 2024, I'm gonna have to be careful as I read through to make sure I don't end up with leaks because the mechanisms that they describe are not perfect and they have issues. So I need to follow the standard, but carefully make sure I don't introduce leaks into my program. I don't know, in the standard they say, I'll have Siri read it, text to speech or whatever.
However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could. However, any value associated to a well-known symbol in a live.
You gotta be kidding me. Is it not working?
Memory resources and implementations. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources and implementations.
Okay, I forgot to turn it on.
However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources and implementations.
So it says,
unlikely to be collected and could leak memory resources and implementations.
so later on in the standard, they address that.
Weak map and weak set are intended to provide mechanisms for dynamically associating state with an object or symbol in a manner that does not leak memory resources if, in the absence of the weak map or weak set instance, the object or symbol otherwise became inaccessible and subject to resource reclamation by the implementation's garbage collection mechanisms.
So as they say,
Weak map and weak set are intended to provide mechanisms.
Intended. 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 You see the word intended?
Intended.
Everyone has intentions. But, I don't know. You kind of get what I mean. I hope. If you don't, whatever. Except here, though, since they have intentions to, like, not have memory leaks, because, like, intended to provide mechanisms. So, like, they have the intention to provide mechanisms for dynamically associating state with an object or a symbol. That's their intention. That does not leak, intended to not leak memory resources. Yet, in the absence, the object or symbol may become inaccessible and subject to resource reclamation by the implementation's garbage collection mechanisms. I'm like trying to read from really far away. It's blurry. So they provide these two sources from 1997 and from 2008. So I would have thought that if this was their intention to not have leaks and like provide mechanisms, that they would have implemented it inside of this documentation. But instead, they just kind of throw it here, like, if you care about memory leaks, whatever, here's some stuff to read. We didn't read it, and even if we did, we didn't bother to put it in. We intended to account for this stuff, but we didn't. So we published the documentation. The year is 2024. Who gives a shit? Screw the customer. It doesn't matter. What's the point? I don't know. That's what their intentions really were. I don't know. I feel like I'm going on and on. I think I made my point. The standard, I don't know how. It's a golden standard. To call it a standard. Sheesh. So, I don't find memory leaks acceptable ever. It shouldn't be possible for there to be a memory leak. If it is, you shouldn't be programming. Whatever. So, this is C code. I talked about optimization last stream. I'm going to keep it simple. Basically, though, math is not real. Math is an order of operations and pattern matching. XOR can replace subtraction if the left-hand side is a power of 2 minus 1, and the right-hand side is 0 or not greater than the right-hand side. And it's a normal set of numbers, 0 and whatever this power of 2 minus 1 is. If that's the case, it's always possible to do the left-hand side, which is the power of 2 minus 1, XOR the right-hand side, which is always within the set of the power of 2 minus 1 subtraction can be replaced with XOR, like right here, whatever. And then this will execute faster than this. Even in Visual Studio, I'm going to show some samples of code, whatever. This subtraction ended up being 3 more instructions than the XOR. And I don't know, Visual Studio, Microsoft Visual Studio, I don't understand how they can make so many instructions for like such a simple operation. They physically set a value to the stack, they drop the stack, change the stack frame, and then they like load it from the stack frame, and the stack frame isn't even based, it's like offset by a certain amount because they have like hidden variables, probably for the this argument, because I think it's C++. I don't know. So I'm gonna like check the disassembly, but I'm not gonna get into like optimizing or whatever. So I'm gonna check the assembly on only this. So this is C code, and you put it in a C compiler, and it makes assembly code, machine code. It's the same thing, different names, possibly different coding, but that depends on the context. So this is Godbolt, whatever, an online compiler. On the left-hand side, I have this code here. Chips equals argx, let's pass in. Potato equals 255, that's a power of 2 minus 1, subtracting chips. And 255 is maxint for unsigned char, and chips is unsigned char. So it's guaranteed that the left hand and the right hand side meet the condition that both are of the same set, and 255 or 256 is a power of 2. So 256 minus 1 is 255, which is max int for char. That's the range, whatever. I lost my train of thought. Anyways, this is what Visual Studio generates for this simple operation. Can you believe that? I really don't believe it. What even? How does it take 1? Let's run keyboard. 2, 3, 4. How does it take 12 instructions? Is that 12? I think it's 12. No, it's 11. Return doesn't count. It's 11. How does it take 11 instructions in assembly to do this? It's an assignment here, which should be optimized. This is the highest whatever optimization mode for Visual Studio. This is the optimized output. How does it take 11 instructions to assign, but it doesn't even get assigned because it gets optimized, so it just puts it here. Actually, let's see what the output is now. Oh my goodness, it's actually smaller. Wow. This compiler sucks. How is it not able to recognize that it can remove the assignment? The optimization is all the way up. Okay, anyways, this compiler, it sucks ass. It sucks poop right out of the butt. This is GCC, or Clang, whatever it's called. It's doing the same thing here. Right here it says Clang. The other one says Visual Studio. So Visual Studio interprets this C code and creates this assembly machine code. GCC sees this C code and then interprets it into this assembly. Now, you don't even have to know assembly. But which one do you think is faster? This assembly? These machine instructions? Where the machine being the CPU that you pay for, that you paid how much money for, and you're getting what kind of performance? Not only is it killing trees and wasting electricity, it's wasting your time because you're waiting. You pay how much for your computer and you get what kind of performance from Microsoft? I don't think that's fair. I think the customer is getting the shit end of the stick. That's why I'm writing a JavaScript engine. Here's my whole point. Move EAX EDI, not AL. This is a register. This is a lower part. This is a 32-bit part. And then the bottom part is 8 bits. So it's 32 bits. This is the 8-bit part. So it's moving to a register and it's inverting it. So it's flipping it to the opposite. It's not negation. It's flipping the value as a binary value. So all the ones become 0, the zeros become 1. That is much simpler and faster than 11 or 9 instructions. So to keep it the same, I'm gonna copy it, paste it back over here because I changed it. This compiler, Visual Studio, should be able to recognize that. If this compiler does, there's no reason why Microsoft is a very large company and they can't afford to optimize code the same way as open source. That's ridiculous. Microsoft is a joke. Now this is 11 machine instructions. And this one's 2. Now you don't even have to know assembly. What sounds like more work for the machine, the CPU to do? A move and then a flip of the bits? Or I'll explain this once and then I'll stop wasting time. Is that more expensive? 2 instructions? Or is this move to stack pointer plus 8 CL? They're moving to the stack pointer. They're adding a displacement, an offset, a field offset of 8. And they're adding 8 because they want to add 8 because they're going to store a 64-bit value even though they're only using 8 bits, they're going to store 8 bits in, they're going to store 1 byte in 8 bits because they're offsetting by 8. And then here, they subtract the stack pointer, 24. They have hidden variables, either debug, or it's this, or it's because it's being virtually dispatched. I don't know, something like that. There's hidden whatever, so they gotta subtract from the stack pointer, or it's because I don't know. They're not using much stack space. It doesn't matter. I don't know what they're doing. This code makes no sense. It's not worth really thinking about. It could be for too many reasons. Okay, so overall, they're moving, they're adding to the stack register an offset. They're preserving like space for 8 bytes when they're only going to use 1 byte to move. So they move to that location. Then they subtract from the stack pointer here. They added 8 here, but it didn't modify it. This subtract modifies it. So it moves the value down 24 because they're subtracting 24. Then they move ZX. So they're going to zero out everything above, I think. I think that's what ZX is. So they're setting EAX to the byte pointer at RSP. What's at RSP? I'm not sure. I don't know, because this was set at 8 and now they're subtracting 24. What the hell is the point of even that? But yeah, and then they're moving AL after they loaded it from the stack. They're moving AL to RSP, which has been subtracted 24. So there's space of 24. Or it's not space of 24. And the stack's going the other way. So they reserve more space before or after. I don't know. This makes no sense. What's going on here? And then they move to EAX what they just set. So they set to the stack here, and then they load the byte from the stack here. Like, do you see how this doesn't make sense? What's the point in moving AL to memory if you're just going to load it directly after from memory? And then they zeroed out again. So, like, this makes no sense at all. And then they move to ECX 255. What's the point? Here's CL. They're moving CL. Let's save it. Maybe they're saving CL on the stack, so they want to preserve it. That's probably what's going on. Alright, I got it. That's what's happening. And since AL passes in the argument, it's fine to destroy it because it's what's passed in. So they have to oh my god, they have to save the value to the stack. But this is a faster way to save it because they're just adding displacement. You don't have to modify the stack pointer. So they optimize this. I got it. I figured it out. They optimize it. What they're optimizing is this. This is what this $1 billion compiler does. It's like 40 gigs to install. They're optimizing this. So is this compiler. They're optimizing it also. How does this compiler create 2 instructions? It's so much better. Oh my god, it's not even funny. Anyways, we're talking about Visual Studio here. This thing is a beast. I mean, it can optimize code, it can make bloated code, it just does what it wants. So, alright, I think I got it now. Back from the top. I need some water. So, because Visual Studio is optimizing this really simple operation here, there's no need for any of this. At least they're optimizing it. So like, it's not needed. It takes more cycles to complete. It wastes time. It wastes energy. It means that your computer, the code, will be running slower, but that doesn't matter. It doesn't. Otherwise, they wouldn't be doing this. So that's why they're doing it. So they gotta optimize it. So right here, it's expensive to like change the stack pointer. So what they do is they leave it and they add displacement. And they're doing a move. I don't know why. I think they're adding 8 also for optimization because they want to keep everything aligned. So technically, I was wrong. They're not wasting space. Instead, they're optimizing because they're like, we gotta, and it's not just optimizing. If they make an exception for anything stored on the stack, it's gonna affect everything below it. So they have to keep everything 8 bytes aligned. So that does make sense, I guess. Okay, so they're optimizing this code here, this variable 255 minus a value. They're optimizing this simple mathematical operation that can literally be done in one instruction. This could be done in one instruction. Except EDI is used to pass in the argument and AL is passed out. If they changed the calling convention, they should just inline this, actually. Really, it needs one instruction, and that's what's going to get at. My code, I would do that. I would not. Because not is the same thing as 255 minus chips. So I'm going to like go over, that's the whole point, whatever. I'm going to like figure this out though. Okay, so that's why I do that. Alright, this I'm going to get through the whole thing. I'm going to explain it. I'm going to dig in. I'm going to learn something. I'm going to get learned. Here we go, getting learned. Move, byte, pointer, register, stack pointer. And it's R because it's 64-bit. E is for 32-bit. And then SP itself is for 16-bit. So they're moving to the stack pointer. They're displacing it by 8 bytes. They're offsetting it by 8 bytes. They're moving CL to the bottom byte of those 8 bytes because they have to keep the stack aligned because everything on the stack needs to be 8-byte aligned, which is 64-bit. And then they subtract from the stack. So this is optimized because now the CPU is able to do this store and this subtraction at the same time because it's out of order execution. So the CPU gets to optimize this. It does these 2 instructions on different ports at the same time. In context, of course. Because nothing really happens at the same time. It's not physically possible. Especially with binary or digital, whatever. Then they have move ZX. I think that means they zero out everything above 32 bits. So they're moving the ZX EAX from the stack pointer that was now accumulated. If they wanted to optimize this, they probably should have just did plus 24, plus 24, plus 24, but that would have been 3 extra displacements, so they optimized it by doing 1 subtraction. So that's very smart of them to do that. They're like saving on instruction cycles. So like instead of like saving on instruction cycles and doing something like this, you know, just like making it 2 simple instructions here. Instead, Microsoft, in their wisdom, they were like, you know what? We're going to do this and we're going to do it right. We're going to like 2 instructions, not enough. No, we're going to have to like use register CL, which means we have to save it to the stack. So let's make sure we save it to the stack. It has to be 8-byte aligned. We're going to make sure that we only adjust the stack pointer after it's been saved to the stack so that the CPU is going to be able to carry out, what's it called? Out of order execution. All right, so that's where we're at. And then Microsoft, the compiler, it's like, all right, I gotta get the argument. Oh, it's on the stack. Oh, it's right here at RSP. Now, this might actually, registry renaming, it might be able to like use this while it's in flight, like in the CPU, on the bus or whatever. So maybe that might be optimized too. So it does this, right after this, bam, it does this. And it moves into EAX, the argument, which is going to be argx. That's this arg. So that's where we're at. That's how far we got. It took 1, 2, 3 machine instructions to get the argument. So, Clang, this compiler, GCC, whatever it's called, it only took 1 instruction. They're doing move, EDI, that's what's being passed in. That's this. So they're doing a move. They're like move to the A register, and then we'll flip it. Well, I'm getting ahead of myself. I'm just saying. They optimize this in 1 move. But Microsoft, being so intelligent, they're like, we gotta do this right. So Microsoft is like, I don't know, this is really, really cool. So Microsoft is like, all right, here we go. Let's compile this to machine code. Computer stuff, baby. So, right now, CL was saved. I don't know why. What even? Why would they do this? This is so dumb. Anyways, after they have fetched EAX, which holds, they fetch the value into EAX, which holds argx. So now they have that value in EAX. So now, instead of, all right, here's where they optimize it again. They're like, you know what? We could do the subtraction here. We could just subtract chips. We could do it right now. But instead, Microsoft's like, you know what? Actually, we zeroed out the upper 32 bits of the 64-bit register, assuming that's what this does. CX. I think that's what it does. It might not be. Assuming so. I don't. This is my first time in x86 64 assembly. I've done 32-bit and stuff and other CPUs, but not 64-bit. But I would assume, oh wait, what's it say? Oh, it gives you info? Oh, that's useful. Copies of contents. And 0 extends the value The size of the converted value depends on operand size attribute. Copies, condense. And 0 extends the value. Okay, so that is what it does. So it's loading the 32-bit part and 0 extending the upper 32. So it's a 64-bit, but they're doing an optimized move from the stack that was accumulated here. So once they get in memory, they go, you know what? This is a 32-bit value. Let's move, because they move here. Let's move AL, which is A, EAX. This is 32-bit. This is 8 bytes. The bottom, 8 bits, I mean. So this is 4 bits. But they're moving 8 because they're zeroing out the upper 4. They're moving 4 from the stack. Right here, they take the byte. The 4, the 8 bits at the bottom. The only 8 bits at the bottom. They take those, right? Now they're going to store that back onto the stack. Because it's what they do. Because they're good at what they do. Alright, so Microsoft. They're like, so we loaded this bad boy up into EAX, and then we stored it, the bottom 8 bits, right back to where it came from. And now what we're going to do is we're going to load up with move CX, we're going to load up EAX right back from where it came from. That's what we do. We're Microsoft. We save, we load up a 32-bit value, zero out the upper 32 bits, and then we're like, you know what? Let's move that value back to where it came from, but only a byte. And then they're like, okay, now let's get it back. And they load up a byte back into a 32-bit register. I don't know why they would do that. That's pointless. It's so pointless. So, I'm getting tired of talking. I'm almost there though. After that, what even? These people are morons. Okay, you see here, they're saving CL on the stack to not destroy it. Then right here, they're moving to ECX 255. They're destroying the value above CL. They're destroying 32 bits. What is the point of that? I don't get it. There's no point for this operation here. They're not even using CL. And when they use it, they overwrite it right here with 255. Okay, so I don't know. That's where we're at. Right now, they have the value. It's in EAX. And now, so that's this, right? That is this. Literally, this is this. It's on the stack. They got it. It took them a load or a store, accumulate the stack. It took a load. It took saving it back and then loading it again. But now they got it. So like, they kind of got their eye off the ball there with those, with that load, store, then load again. But now they're back on track. So, at this point, they're moving to ECX 255, which is right here. They're right now, they're going to do potato minus chips. Here we go. Here is like, this is it. This is it. So, we got move ECX 255. Then we got subtract ECX EAX. You see this? ECX is 255. EAX is right here. That was loaded here. And then was stored back to where it came from, here. and then they loaded it up again here because it's here, here, here. So that's a load, a store back to where it came from, and a load to where it came from, back from where it was. And then they moved to ECX 255. So they finally got to here. So they're doing potato minus chips. So now they're subtracting chips from potato with subtract, because it goes on the left hand side. This gets applied, this gets modified. Alright, we're almost there. Now, after all that, they have to clean up, because they touched the stack, they saved stuff, they loaded stuff, they did whatever. So now this is done, but they can't just return yet. It's not done yet. No, we're just getting started, because there's like 4 more instructions. The CPU is like, why am I doing all of this work? I could be running other programs, I could be multitasking, but instead I'm like loading a value, saving a value, loading it again where it came from, where it was saved to from where it was at, and I'm like, the CPU's like, what the hell is going on? But I'm gonna do what I do. The CPU is a real trooper. So at this point, it could return, but it can't, because it did what it needed to do in these 1, 2, 3, 4, 5, 6, 7. So it took Microsoft 7 instructions to carry out potato minus chips. Now, it took Clang 2 instructions. We're talking about a single move. They're not even touching the stack. They're just all register. This is zippity quick. Just like boom. Like it's done. CPU's like, alright, back to threading. Back to multitasking. The CPU can do whatever it wants. In 2 instructions. Done. Bon appetit. It's done. Super fast. So, Microsoft needed more than 2. But it's Microsoft, you know. They're good at what they do. So what they did, though, even though it took them 7 instructions, when it could have been 2, at least they optimized it, you know? And they're being safe here. They're making sure that the top of the 64-bit register of EAX, they're making sure it's zeroed out. So they're being safe, if anything. Okay, so at this point, they've done the subtraction. Now they got to clean up. Not only clean up, but EAX is generally used to hold what's returned. So they did the subtraction here. They subtracted chips. Was it chips? Yes, they subtracted chips from potato. Why would they do it that way? I don't know why they're doing this. They could like save so many instructions in so many places. This could have been 2 instructions. Anyways, since they did it this way, ECX holds the result. EAX needs to be passed back. Oh my god, are you kidding me? Okay, so here's where we're at. They finished the subtraction, whatever. So now they got to pass back the result. This is where Microsoft, the Microsoft compiler, it rolls up its sleeves. It's like, I've got this in the bag. I subtracted from potato chips. This thing is in the bag. Microsoft's got this. So now, after all that, that was funny, wasn't it? Yes, real funny. Chips in the bag. Alright, so this is where we're at. Microsoft, they've done a move a subtraction, a stack. They did a move, another move. They did a move again, and then they moved. They're in motion, baby. Microsoft, they're just moving all over the place. Move this, move that. Freaking move domains. Just freaking move. And then they're like, subtract. It's like, done. They subtracted. Mission's complete. Now they gotta like, everything's done. That's it. Chips in the bag. But, there's always a but. The way that they carried this out. Since ECX holds a result, they're going to have to assign it the EAX, because that's what is used to pass it back. So here, we got another move, a move. So they finished it up, and now they're back on move. So they're like, EAX, it's going to hold the result. So they move it. And then Microsoft is like, you know what? We haven't done a load or a store from the stack. They're feeling a little bit anxious. So they're like, you know what? We have to do one more store. Let's save it. Let's save it to the stack. They just can't resist saving the result to the stack. So here, right here, operation's complete. And they're like, shit, we gotta return it in EX. No big problem. So right here, they move it to EX. But then they're like, we gotta save to the stack. You know we gotta save to the stack. So then, right here, this move here, this byte pointer, RSP, see RSP, stack pointer, they move it to the stack right here. They're moving A to the stack. So the chips are not in the bag yet, almost there, because now they moved it to the stack. But the value is still in EAX. All they did was make a copy to the stack. But being that it's a tradition of Microsoft, they have a tradition. It's called save something to the stack and then load it from the stack. As you see here, they load something from the stack and then they save it to the stack and then they load it from the stack. You see how this is the same? It highlights. You see the highlight? It's the same thing. That's why it's highlighted, because it's the same text and it's the same register. So they load, they store, and then they load. So whenever they store, they're gonna have to load it. And the CPU is like, come on, man, I want to go home. I got other threads to execute. I'm trying to like run this video game, and they're watching a video on YouTube. Just get to the point. And Microsoft's like, all right, I guess we could get to the point, because we did do 255 minus chips. This potatoes, it's in the bag. Let's take it home. So now, Microsoft, they're like, all right, so like, we can't break their tradition. AL still holds the value. But since we did save it to the stack here. It's what we do. What we're going to have to do is load it. We're going to have to load it from the stack. And not only load it, we're going to do the special load where it zeroes out the upper 32 bits. Because we got to be safe. I mean, we literally just saved this thing to the stack. We're going to get it from the stack. We got to be safe about it. We got to make sure the upper 32 bits are not set. Did we save only 8 bits of the register? Let's zoom in here. Yeah, they did. They only saved 8 bits. But tradition says, as above, it is tradition, not as it says. So what they have to do then, since they only saved 8 bits, they're going to have to load 32 bits. So right here, EAX, that's the 32-bit of the 8 bits below it. So right here, they saved it to the stack, now they load it again. But they're not done yet. Microsoft, they almost took it home. So now they're like, you know what? We can't forget that we adjusted the stack by 24 bytes on entry. Why did we do that? It doesn't matter. All that matters is we did our mission. We did potato minus chips. Let's throw in the towel, get this thing over with. So now Microsoft's like, all right, so we got a result. Into the register needs to be in. We could have rewritten this whole thing. This whole thing could have been written in 2 instructions, just like Clang. As you see, 2 instructions Clang. But Clang is not Microsoft. They're 2 different compilers. Clang doesn't have the money that Microsoft has. Clang is open source. So since Microsoft has money, they're able to afford all these fancy optimization tricks and such. Okay, so now EAX, it holds the result. Absolutely, positively, there's no way it doesn't. How do you know it holds the result? Because it was assigned here, right? So like since it was assigned, it has value. On top of that, they also stored the low 8 bits to the stack, right? So like not only does EAX have value, but it's been copied to the stack. And then they load it again, stack. They load EAX. I don't know what the point is, because now they just loaded possible garbage from the stack. Because they set 8 bits, but then they're loading 32. What's the point in zeroing out the 32 above the bottom 32 if they already have garbage? Because who knows what was on the stack? I don't know. Microsoft knows what they're doing. So this is the point where they're like, EAX, it holds the result. We are absolutely certain that we're ready to return to the skull. We're ready to give the CPU a break so it can run more of our shitty code. I mean, our highly optimized, expensive ass, super fancy code. So now they're like, all right, we're going to adjust the stack pointer. We're going to add 24 to RSP because we did subtract above. We got to clean up the mess we made. I mean, clean up the optimizational wonderland that we have created for our user using our product. So they dropped the stack here. I mean, add, subtract, same thing. So now they add to the stack 24. They restore the whole thing back to the way it was. Did it take them 11 instructions? Yes. But did they do it good? Did they do it the best? Most definitely. If anybody could do this potato minus chips, if anybody could bag this thing this bad, as in good, like bad boy, this bad, nobody could do it as bad as Microsoft. I mean, Microsoft, they are bad to the bone. So all of that, in summary, be carried out in one instruction. which is not AL. That's all they had to do. That whole thing could have been done in one instruction. Now I'm a human. I'm not a compiler. So luckily, I won't have those same pitfalls as a compiler. So when I write code for my JavaScript engine, it's going to have a little bit of C in it, but the major parts, I'm going to write them in assembly. So, in cases where compilers do things like this, for something this simple, if I write my JavaScript engine in C and the major parts in assembly, and if I also implement things like the AVX instructions or the FMA or the AVX, I said AVX, or the SSE, if I account for these too, not just the general purpose registers, if I do these things, I make sure like things are clean. I don't ever do like this kind of a thing, and I always like optimize things to a single instruction like this. If I can do that, then I am literally guaranteed that my JavaScript engine will be the fastest JavaScript engine implementation in existence. And I get small money. So I don't know. That was so much talking. I'll be Siri, read the standard. Machine code is so much fun. Siri's not working. Is this working? Okay, I gotta restart. That's great. I'll BRB. This stuff is shit. Testing. My bad. Okay, so I have to get back on track. I am writing assembly, whatever, to figure it out, because 64-bit assembly is like new or whatever. I still have to get ARM64. That's like later. I should probably do it sooner than later. So sooner rather than later, I'm gonna do that or figure that out, whatever, for ARM64. But for now, I'm just trying to get x86-64. So I have this branchless routine. I need to drink some water. And it should turn a nibble into the hexadecimal representation as a char code point character to print to a string in this window of this exe that is generated, and it outputs to here. So right now it works with this number 2 when I set the nibble of 2 as a value to the AL register that I pass in to the macro, which has a routine that I'm going to check. Dang it, I closed the wrong thing. So anyways, these 2 files, they are needed. Because I'm going to, I don't know, remake it, whatever. This calls an ASM assembler, the x86_64 assembler. There's different kinds of assemblers or whatever. I'm using this whatever. Paste the command. It opens this file. Here, whatever. There's a bunch of other stuff. From the days before this, whatever. And then it made this file here. This is the object file. Now, Visual Studio, command prompt. I press up to like paste the command because I already pasted it before. And I hit enter. It'll create the executable by linking and making the object. And it made the executable. So when I click on it or whatever, there it is. It still prints 2 because I didn't change the program yet. Now I gotta test the program. I gotta pass in 0 to 16 to make sure, 0 to 15 to make sure it prints each of them as 0 to 9, then A to F. Then I'm gonna make a loop, and then I'll call this 15 times because 16 times, 16 length times, because there's 8 bytes in a 64-bit value, but that's 16 nibbles because a nibble is 4 bits and a byte is 8. And what I'm going to do is I'm going to print the 8-byte address is to this window so we can like read it. I have to check the address because when I change the program mode to absolute, when I change this to absolute, it turns off some of the default behaviors. And I think it makes different addresses when assigning a label to a move. But I don't know. So I'm gonna turn it off. I gotta like print the address so I will know. Because I asked chatbot, it makes no sense. So I'm gonna like print the addresses, figure whatever out, and then I have some code to test, to speed test, to see if I can make code that's faster than the compiler. I'm pretty sure I can, but I'm just trying to like figure out 64-bit assembly, and I'll feel comfortable saying that I can if I can. If I do a couple routines and it's like obvious I can do it, then it means like when I get to the rest of JavaScript Engine, I'll be guaranteed that it's gonna be faster. So I'm gonna open up the PDFs, whatever, again on this computer. I have Siri read the standard, the ECMA JavaScript standard, and then I'm gonna get to work. I need to get this char code thing working, and then I gotta speed test stuff, and I'm gonna get back to like parsing the program, I guess. And then I have a program, a backup that's broken. I don't know how it broke because I haven't been running it, but it's broken. So I gotta get it back up, find one that works, and hope that nothing changed. Because if it did, then I gotta update the backup. So I don't know. See how far I can get today. And I don't have to use a macro, especially branchless. It's just because I can. I'm trying to figure out 64-bit assembly, and I want to try to write something that's faster than the compiler. So I don't know, this is like, I think it's a good test or whatever. That way I can use this code, whatever, if I need it. Otherwise, I would have to like think up scenarios of things to test and then test it, and then like I might not use it. So I don't know. I'm gonna get to work and get stuff printing to this window. Super, super fun stuff.
Comment. Token regular expression literal. Point 1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals and regular expression literals. ZWNJ and ZWJ are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, ZWNJ and ZWJ may also be used in an identifier after the first character, BOM, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order, BOM. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files, BOM, characters are treated as white space characters, see 7.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 1. Code unit value, U200C, U200C, UFF.2 white space, name, 0 width non-joiner 0 width joiner byte, order mark, formal name, ZWNJ, ZWJ, BOM, usage, identifier part white space, Table 1, format control character usage. White space characters are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space characters may occur between any two tokens and at the start or end of input. White space characters may also occur within a string literal or a regular expression literal, where they are considered significant characters forming part of the literal value, or within a comment, but cannot appear within any other kind of token. The ECMAScript white space characters are listed in Table 2. 4. Copyright sign, ECMA International 2009. Code unit value, U0009, U000B, U000C, U0020, U00A0, UFF. Other categories EDS, name, tab, vertical tab, form feed, space, no break space byte, order mark any other Unicode space separator, formal name, tab, VT, FF, SP, NBSP, BOM, USP. Table 2. White space characters. ECMAScript implementations must recognize all of the white space characters defined in Unicode 3.0. Later editions of the Unicode standard may define other white space characters. ECMAScript implementations may recognize white space characters from later editions of the Unicode standard. Syntax: white space, tab, VT, FF, SP, NBSP, BOM, USP. Point 3 line terminators. Like white space characters, line terminator characters are used to improve source text read ability and to separate tokens, indivisible lexical units, from each other. However, unlike white space characters, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 7.9. A line terminator cannot occur within any token except a string literal. Line terminators may only occur within a string literal token as part of a line continuation. A line terminator can occur within a multi-line comment. 7.4. But cannot occur within a single line comment. Line terminators are included in the set of white space characters that are matched by the S-class in regular expressions. The ECMAScript line terminator characters are listed in Table 3. Table 3. Line terminator characters. Code unit value, U000A, U000D, U2028, U2029. Name, line feed, carriage return line separator paragraph separator, formal name, LFCRLS, PS. Only the characters in Table 3 are treated as line terminators. Other new line or line breaking characters are treated as white space but not as line terminators. The character sequence, CR, LF, is commonly used as a line terminator. It should be considered a single character for the purpose of reporting line numbers. ECMA International 2009-15. Syntax: line terminator, LF, CRLS, PS. Line terminator sequence, LF, CR look ahead, LF, LS, PS, CRLF. Point 4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any character except a line terminator character, and because of the general rule that a token is always as long as possible. A single line comment always consists of all characters from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important, because it implies that the presence or absence of single-line comments does not affect the process of automatic semicolon insertion. See 7.9. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator character, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax. Comment. Multi-line comment, single-line comment, multi-line comment charsopt, multi-line comment chars, multi-line not asterisk char, multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, multi-line comment charsopt, post asterisk comment charsopt, multi-line not asterisk char, source character but not asterisk, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, char, source character but not / or asterisk, single line comment charsopt, single line comment chars, single line comment char, single line comment charsopt. 6. ECMA International 2009. Single line comment char, source character but not line terminator. Point 5 Token syntax. Token. Identifier name, punctuator, numeric, literal, string, literal. Note the div punctuator and regular expression literal productions define tokens, but are not included in the token production. Point 6 Identifier names and identifiers. Identifier names are tokens that are interpreted according to the grammar given in the identifiers section of Chapter 5 of the Unicode Standard, with some small modifications. An identifier is an identifier name that is not a reserved word. C7, 6, 1. The Unicode identifier grammar is based on both normative and informative character categories specified by the Unicode Standard. The characters in the specified categories in version 3.0 of the Unicode Standard must be treated as in those categories by all conforming ECMAScript implementations. This standard specifies specific character additions. The $, and the underscore are permitted anywhere in an identifier name. Unicode escape sequences are also permitted in an identifier name, where they contribute a single character to the identifier name, as computed by the CV of the Unicode escape sequence. C7, 8, 4. The preceding the Unicode escape sequence does not contribute a character to the identifier name. A Unicode escape sequence cannot be used to put a character into an identifier name that would otherwise be illegal. In other words, if a Unicode escape sequence
It looks like it doesn't work, so I didn't convert it 100% correct. So, I'm gonna try xlat. It's like a old x86 instruction, whatever. I already have an array. I think I still have an array up at the top, whatever. Yeah, so here. So what I'm gonna do instead is I'm gonna just grab it from this array, print the character. Keep it stupid simple.
source text
Later on, I'll write assembly. And I also need to write code and not optimize it first. I don't know, I was hoping I get lucky. Normally, I write code, it just works. I haven't written assembly in a long time. Rusty. So I don't know.
Unicode letter. Unicode.
I'm gonna like load up from that byte array instead now. And I don't know. I could get done. This takes way too long to like keep playing around assembly. I have to save assembly
Modify letter LM
like when I have all the mechanisms in place.
mark any character in the Unicode categories non-spacing mark MN or combining spacing mark MC. Unicode
Like if I start writing assembly and stuff before I get to this point,
to punctuation. Any
it'll never end. So I gotta like get this stuff done, get the engine ready, all the mechanisms set up, and then very last, or like at least after half of it's set up,
keyword
then I'll get into assembly. Otherwise, everything needs to be optimized if it's in assembly. And it's like slightly more difficult to change because it has a link to the C program. So like, I kind of have the hang of it now. Later on, I'll really get into like writing assembly. But I still am gonna like speed test some stuff. First I gotta get it just printing this window. And to get it, just bring to this window. And to make sure it's like printing right, whatever. That's all I gotta do. So I'm gonna not bother with this right now. I'll try to like optimize stuff later. And this probably isn't even optimized. If it did work, I would have to rewrite it 3-4 more times. So I'm gonna like get this stuff to print. Then I'm gonna speed test stuff. And then maybe I'll speed test this. I don't know. I have a bunch of things I can test. I'm gonna test something. First, I just gotta get stuff to print to the window. That's my main goal. I still have to get the timer. I'm gonna get something done, so I don't know. This didn't work though. Next time, it will. I gotta tweak it. Or whatever. So I'm gonna get back to work. That was disappointing. I'll optimize it later.
2009. 9. Semantics. The value of the null literal null is the sole value of the null type, namely null, 8.2 Boolean literals syntax. Boolean literal. True, false. Semantics. The value of the Boolean literal true is a value of the Boolean type, namely true. The value of the Boolean literal false is a value of the Boolean type, namely false, 8.3 numeric literals syntax. Numeric literal, decimal literal, hex integer literal, decimal literal, decimal integer literal, decimal digits opt, decimal digits exponent part opt, decimal integer literal exponent part opt, decimal integer literal, 0, non-zero digit, decimal digits opt, decimal digits, decimal digit, decimal digits, decimal digit, decimal digit, 1 of 123,456,789, non-zero digit, 1 of 123,456,789, exponent part, exponent indicator signed integer, exponent indicator, 1 of the signed integer, decimal digits, decimal digits, decimal digits, hex integer literal, 0x hex digit, 0x hex digit, exponent part opt, 0, ECMA International 2009, hex integer literal hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, abdef ABCDEF. The source character immediately following a numeric literal must not be an identifier start or decimal digit. Note, for example, 3 inches is an error and not the two input elements 3 and in. Semantics. A numeric literal stands for a value of the number type. This value is determined in 2 steps. First, a mathematical value, MV, is derived from the literal. Second, this mathematical value is rounded as described below. The MV of numeric literal, decimal literal is the MV of decimal literal. The MV of numeric literal, hex integer literal is the MV of hex integer literal. The MV of decimal literal, decimal integer literal is the MV of decimal integer literal. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal plus the MV of decimal digits times 10n, where n is the number of characters in decimal digits. The MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal times 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits times 10n times 10e, where n is the number of characters in decimal digits and e is the MV of exponent part. The MV of decimal literal decimal digits is the MV of decimal digits times 10n, where n is the number of characters in decimal digits. The MV of decimal literal decimal digits exponent part is the MV of decimal digits times 10en, where n is the number of characters in decimal digits and e is the MV of exponent part. The MV of decimal literal decimal integer literal is the MV of decimal integer literal. The MV of decimal literal decimal integer literal exponent part is the MV of decimal integer literal times 10e, where e is the MV of exponent part. The MV of decimal integer literal 0 is 0. The MV of decimal integer literal non-zero digit decimal digits is the MV of non-zero digit times 10n plus the MV of decimal digits, where n is the number of characters in decimal digits. The MV of decimal digits decimal digit is the MV of decimal digit. The MV of decimal digits decimal digit is the MV of decimal digits times 10 plus the MV of decimal digit. The MV of exponent part exponent indicator signed integer is the MV of signed integer. The MV of signed integer decimal digits is the MV of decimal digits. The MV of signed integer plus decimal digits is the MV of decimal digits. The MV of signed integer decimal digits is the negative of the MV of decimal digits. The MV of decimal digit 0 or of hex digit 0 is 0. The MV of decimal digit 1 or of non-zero digit 1. The MV of decimal digit 2 or of non-zero digit 2. The MV of decimal digit 3 or of non-zero digit 3. The MV of decimal digit 4 or of non-zero digit 4. The MV of decimal digit 5 or of non-zero digit 5. The MV of decimal digit 6 or of non-zero digit 6. The MV of decimal digit 7 or of non-zero digit 7. The MV of decimal digit 8 or of non-zero digit 8. The MV of decimal digit 9 or of non-zero digit 9. The MV of hex digit A or of hex digit A is 10. The MV of hex digit B or of hex digit B is 11. ECMA International 2009. 1 or of hex digit 1 is 1 or of hex digit 2 is 2 or of hex digit 3 is 3 or of hex digit 4 is 4 or of hex digit 5 is 5 or of hex digit 6 is 6 or of hex digit 7 is 7 or of hex digit 8 is 8 or of hex digit 9 is 9, the MV of hex digit C or of hex digit C is 12. The MV of hex digit D or of hex digit D is 13. The MV of hex digit E or of hex digit E is 14. The MV of hex digit F or of hex digit F is 15. The MV of hex integer literal 0x hex digit is the MV of hex digit. The MV of hex integer literal 0x hex digit is the MV of hex digit. The MV of hex integer literal hex digit is the MV of hex integer literal times 16 plus the MV of hex digit. Once the exact MV for a numeric literal has been determined, it is then rounded to a value of the number type. If the MV is 0, then the rounded value is plus 0. Otherwise, the rounded value must be the number value for the MV, as specified in 8.5, unless the literal is a decimal literal and the literal has more than 20 significant digits. In which case the number value may be either the number value for the MV of a literal produced by replacing each significant digit after the 20th with a 0 digit, or the number value for the MV of a literal produced by replacing each significant digit after the 20th with a 0 digit and then incrementing the literal at the 20th significant digit position. A digit is significant if it is not part of an exponent part and it is not 0, or there is a non-zero digit to its left and there is a non-zero digit not in the exponent part to its right. A conforming implementation, when processing strict mode code, C1011, must not extend the syntax of numeric literal to include octal integer literal as described in B1.1, 8.4 string literals. A string literal is 0 or more characters enclosed in single or double quotes. Each character may be represented by an escape sequence. All characters may appear literally in a string literal except for the closing quote character, backslash, carriage return, line separator, paragraph separator, and line feed. Any character may appear in the form of an escape sequence. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character, double string character sopt, single string characters, single string character, single string character sopt, double string character, source char, actor but not double quote or backslash or line terminator escape sequence, line continuation, single string character, source character but not single quote or backslash or line terminator escape sequence, line continuation, line terminator sequence. 2. ECMA International 2009. Escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Character escape sequence. Single escape character. Non-escape character. Single escape character. 1 of BFNRTV. Non-escape character. Source character but not escape character or line terminator. Escape character. Single escape character. Decimal digit. XU. Hex escape sequence. X hex digit. Unicode escape sequence. U hex digit. The definitions of the non-terminal hex digit is given in 7.6. Source character is defined in clause 6. Semantics. A string literal stands for a value of the string type. The string value, SV, of the literal is described in terms of character values, CV, contributed by the various parts of the string literal. As part of this process, some characters within the string literal are interpreted as having a mathematical value, MV, as described below or in 7, 8, 3. The SV of string literal is the empty character sequence. The SV of string literal is the empty character sequence. The SV of string literal double string characters is the SV of double string characters. The SV of string literal single string characters is the SV of single string characters. The SV of double string characters. Double string character is a sequence of one character. The CV of double string character. The SV of double string characters. Double string characters is a sequence of the CV of double string character followed by all the characters in the SV of double string characters in order. The SV of single string characters. Single string character is a sequence of one character. The CV of single string character. The SV of single string characters. Single string characters is a sequence of the CV of single string character followed by all the characters in the SV of single string characters in order. The SV of line continuation, line terminator sequence is the empty character sequence. The CV of double string character, source character but not double quote or backslash or line terminator is the source character itself. The CV of double string character, escape sequence is the CV of the escape sequence. The CV of single string character, source character but not single quote or backslash or line terminator is the source character itself. The CV of single string character, escape sequence is the CV of the escape sequence. The CV of escape sequence, character escape sequence is the CV of the character escape sequence. ECMA International 2009-23, the CV of escape sequence. 0. Look ahead decimal D. Get is a null character. Unicode value 0000. The CV of escape sequence. Hex escape sequence is the CV of the hex escape sequence. The CV of escape sequence. Unicode escape sequence is the CV of the Unicode escape sequence. The CV of character escape sequence. Single escape character is the character whose code unit value is determined by the single escape character according to Table 4. Table 4. String single character escape sequences. Escape sequence CTNVF. Code unit value U0008, U0009, U000A, U000B, U000C, U000D, U0022, U0027, U005C. Name symbol, backspace, BS, horizontal tab, HT, line feed, new line, LF, vertical tab, VT, form feed, FF. Carriage return CR double quote single quote backslash, comma the CV of character escape sequence. Non-escape character. The CV of non-escape character. Source character but not escape character or line terminator is the source character itself. The CV of hex escape sequence. X hex digit is the character whose code unit value is 16 times the MV of the first hex digit plus the MV of the second hex digit. The CV of Unicode escape sequence. U hex digit is the character whose code unit value is 4096 times the MV of the first hex digit plus 256 times the MV of the second hex digit plus 16 times the MV of the third hex digit plus the MV of the fourth hex digit. A conforming implementation when processing strict mode code. C10 1. 1. May not extend the syntax of escape sequence to include octal escape sequences described in B. 1.2. Note: a line terminator character cannot appear in a string literal, except as part of a line continuation to produce the empty character sequence. The correct way to cause a line terminator character to be part of the string value of a string literal is to use an escape sequence such as N or U000 8.5 regular expression literals. A regular expression literal is an input element that is converted to a regexp object. See 15.10 each time the literal is evaluated. Two regular expression literals in a program evaluate to regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp, C15.10.4, or calling the regexp constructor as a function, 15.10.3. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The strings of characters comprising the regular expression body and the regular expression flags are passed uninterpreted to the regular expression constructor, which interprets them according to its own, more stringent grammar. An implementation may extend the regular expression constructor's grammar, but it must not extend the regular expression body and regular expression flags productions or the product ions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags. 4. ECMA International 2009 is the CV of the non-escape character. Regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminator but not or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, regular expression char, regular expression non-terminator but not or, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class chars, regular expression class chars, empty, regular expression class chars, regular expression class char, regular expression class char, regular expression non-terminator but not, or, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression flags, empty, regular expression flags identify part. Note: regular expression literals may not be empty. Instead of representing an empty regular expression literal, the characters start a single line comment. To specify an empty regular expression, use Dart semantics. A regular expression literal evaluates to a value of the object type that is an instance of the standard built-in constructor regexp. This value is determined in two steps. First, the characters comprising the regular expression's regular expression body and regular expression flags production expansions are collected uninterpreted into two strings pattern and flags, respectively. Then each time the literal is evaluated, a new object is created as if by the expression new regexp, pattern, flags, where regexp is the standard built-in constructor with that name. The newly constructed object becomes the value of the regular expression literal. If the call to new regexp would generate an error as specified in 151041, the error must be treated as an early error. Clause 16.9 Automatic semicolon insertion. Certain ECMAScript statements, empty statement, variable statement, expression statement, do-while statement, continue statement, break statement, return statement, and throw statement must be terminated with semicolons. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. ECMA International 2009-25. 7.9.1 Rules of automatic semicolon insertion. There are 3 basic rules of semicolon insertion. When, as the program is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar, then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is when, as the program is passed from left to right, the end of the input stream of tokens is encountered and the parser is unable to parse the input token stream as a single complete ECMAScript program. Then a semicolon is automatically inserted at the end of the input stream. When, as the program is passed from left to right, a token is encountered that is allowed by some production of the grammar. But the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production. And therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be passed as an empty statement or if that semicolon would become one of the 2 semicolons in the header of a for statement C1, 2, 6, 3. Note, the following are the only restricted productions in the grammar. Postfix expression, left-hand side expression, no line terminator here, plus left-hand side expression, no line terminator here. Continue statement, continue, no line terminator here, identify rot. Break statement, break, no line terminator here, identify rot. Return statement, return, no line terminator here, expression ought. Throw statement, throw, no line terminator here, expression. The practical effect of these restricted productions is as follows. When a or token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the or token, then a semicolon is automatically inserted before the or token. When a continue, break, return, or throw token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, or throw token. The resulting practical advice to ECMAScript programmers is, a postfix or operator should appear on the same line as its operand. An expression in a return or throw statement should start on the same line as the return or throw token. The identifier in a break or continue statement should be on the same line as the break or continue token. 6. Copyright sign, ECMA International 2009. 7.9. 2 examples of automatic semicolon insertion. The source, 12.3, is not a valid sentence in the ECMAScript grammar, even with the automatic semicolon insertion rules. In contrast, the source, 123, is also not a valid ECMAScript sentence, but is transfer made by automatic semicolon insertion into the following, 1, 2, 3, which is a valid ECMAScript sentence. The source, 4a, B, is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the 2 semicolons in the header of a for statement. The source is transformed by automatic semicolon insertion into the following, return, a +b. Note the expression a +b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. The source is transformed by automatic semicolon insertion into the following, a = b. ++c. Note the token ++ is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and ++. The source, if a B else C equals D is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point. Because an automatically inserted semicolon would then be passed as an empty statement. The source equals B plus C, D plus C print is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call equals B plus C, D plus C print, return a plus B equals B plus C, ECMA International 2009-27. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. Types. Algorithms within this specification manipulate values, each of which has an associated type. The possible value types are exactly those defined in this clause. Types are further subclassified into ECMAScript language types and specification types. An ECMAScript language type corresponds to values that are directly manipulated by an ECMAScript programmer using the ECMAScript language. The ECMAScript language types are undefined, null, boolean, string, number, and object. A specification type corresponds to meter values that are used within algorithms to describe the semantics of ECMAScript language constructs and ECMAScript language types. The specification types are reference, list, completion, property descriptor, property identifier, lexical environment, and environment record. Specification type values are specification artifacts that do not necessarily correspond to any specific entity within an ECMAScript implementation. Specification type values may be used to describe intermediate results of ECMAScript expression evaluation, but such values cannot be stored as properties of objects or values of ECMAScript language variables. Within this specification, the notation type, X, is used as shorthand for the type of X, where type refers to the ECMAScript language and specification types defined in this clause. Point 1. The undefined type. The undefined type has exactly one value, called undefined. Any variable that has not been assigned a value has the value undefined. 8.2. The null type. The null type has exactly one value, called null. 8.3. The Boolean type. The Boolean type represents a logical entity having two values, called true and false. 8.4. The string type. The string type is the set of all finite ordered sequences of 0 or more 16-bit unsigned integer values, elements. The string type is generally used to represent textual data in a running ECMAScript program, in which case each element in the string is treated as a code unit value. See clause 6. Each element is regarded as occupying a position within the sequence. These positions are indexed with non-negative integers. The first element, if any, is at position 0, the next element, if any, at position 1, and so on. The length of a string is the number of elements, that is, 16-bit values within it. The empty string has length 0 and therefore contains no elements. When a string contains actual textual data, each element is considered to be a single UTF-16 code unit. Whether or not this is the actual storage format of a string, the characters within a string are numbered by their initial code unit element position as though they were represented using UTF-16. All operations on strings, except as otherwise stated, treat them as sequences of undifferentiated 16-bit unsigned integers. They do not ensure the resulting string is in normalized form, nor do they ensure language-sensitive results. Note the rationale behind this design was to keep the implementation of strings as simple and high-performing as possible. The intent is that textual data coming into the execution environment from outside, for example, user input, text read from a file or received over the network, etc., be converted to Unicode normalized form. C before the running program. 8. Copyright sign. ECMA International 2009 sees it. Usually this would occur at the same time incoming text is converted from its original character encoding to Unicode, and would impose no additional overhead. Since it is recommended that ECMAScript source code be in normalized form. C, string literals are guaranteed to be normalized, if source text is guaranteed to be normalized, as long as they do not contain any Unicode escape sequences. Point 5. The number type, E between various not a number values. But such behavior is implementation dependent. To ECMAScript code, all NaN values are indistinguishable from each other. There are two other special values, called positive infinity and negative infinity. For brevity, these values are also referred to for expository purposes by the symbols plus and, respectively. Note that these two infinite number values are produced by the program expressions plus infinity, or simply infinity and infinity. Note that there is both a positive 0 and a negative 0. For brevity, these values are also referred to for expository purposes by the symbols +0 and 0, respectively. Note that these two different zero number values are produced by the program expressions +0, or simply 0, and -0, SM2E, where S is +1 or 1, M is a positive integer less than 253 but not less than 252, and E is an integer ranging from 1074 to 971, inclusive. The remaining 90071992547409990, that is, 253 values are denormalized, having the form SM2E, where S is +1 or 1, M is a positive integer less than 252, and E is 1074. Note that all the positive and negative integers whose magnitude is no greater than 253 are representable in the number type. Indeed, the integer 0 has two representations, +0 and -0. A finite number has an odd significand if it is non-zero and the integer M used to express it, in one of the two forms shown above, is odd. Otherwise, it has an even significand. In this specification, the phrase the number value for x where x represents an exact non-zero real mathematical quantity which might even be an irrational number such as b means a number value chosen in the following manner. Consider the set of all finite values of the number type, with 0 removed and with two additional values added to it that are not representable in the number type, namely 21,024, which is +1 times 253 2,971, and 21,024, which is 1 times 253 2,971. Choose the member of this set that is closest in value to an x if two values of the set are equally close. Then the one with an even significand is chosen. For this purpose, the two extra values 21,024 and 21,024 are considered to have even significance. Finally, if 21,024 is chosen, replace it with plus. If 21,024 is chosen, replace it with. If +0 was chosen, replace it with 0 if and only if x is less than 0. Any other chosen value is used unchanged. The result is the number value for x. This procedure corresponds exactly to the behavior of the IEEE 754 round to nearest mode. ECMA International 2009-29. Some ECMAScript operators deal only with integers in the range 231 through 231.1, inclusive, or in the range of 0 through 232.1, inclusive. These operators accept any value of the number type but first convert each such value to one of 232 integer values. See the descriptions of the int32 and int32 operators in 9.5 and 9.6, respectively. Point 6. The object type. An object is a collection of properties. Each property is either a named data property, a named accessor property, or an internal property. A named data property associates a name with an ECMAScript language value and a set of Boolean attributes. A named accessor property associates a name with one or two accessor functions and a set of Boolean attributes. The accessor functions are used to store or retrieve an ECMAScript language value that is associated with the property. An internal property has no name and is not directly accessible via ECMAScript language operators. Internal properties exist purely for specification purposes. There are two kinds of access for named, non-internal properties: get and put, corresponding to retrieval and assignment, respectively. 6.1 Property attributes. Attributes are used in this specification to define and explain the state of named properties. A named data property associates a name with the attributes listed in Table 5. Value configurable. Any ECMAScript language type Boolean. Boolean. The value retrieved by reading the property. If false, Attempts by ECMAScript code to change the properties attribute using if false. Attempts to delete the property, change the property to be an accessor property, or change its attributes other than will fail. Table 5. Attributes of a named data property. Attribute name, value domain, description. A named accessor property associates a name with the attributes listed in Table 6. 0. Copyright sign. ECMA International 2009. Boolean, if true. The property is to be enumerated by a for an enumeration. C1 2 6 4. Otherwise, the property is said to be non-enumerable. If false, attempts to delete the property, change the property to be a data property, or change its attributes will fail. Table 6. Attributes of a named accessor property. Attribute name, value domain, description, object or undefined. If the value is an object, it must be a function object. The function's internal method, 8, 6, 2, is called with an empty arguments list to return the property value each time a get access of the property is performed, object or undefined. If the value is an object, it must be a function object. The function's internal method, 8, 6, 2, is called with an arguments list containing the assigned value as its sole argument each time a set access of the property is performed. The effect of a property's internal method, if the value of an attribute is not explicitly specified by this specification for a named property, the default value defined in Table 7 is used. Table 7. Default attribute values. Attribute name, default value, undefined, set, 6.2 object internal properties and methods, undefined, false, false. This specification uses various internal properties to define the semantics of object values. These internal properties are not part of the ECMAScript language. They are defined by the specification purely for expository purposes. An implementation of ECMAScript must behave as if it produced and operated upon internal properties in the manner described here. The names of internal properties are enclosed in double square brackets. When an algorithm uses an internal property of an object and the object does not implement the indicated internal property, a type error exception is thrown. The Table 8 summarizes the internal properties used by this specification that are applicable to all ECMAScript objects. The Table 9 summarizes the internal properties used by this specification that are only applicable to some ECMAScript objects. The descriptions in these tables indicates their behavior for native ECMAScript objects, unless stated otherwise in this document for particular kinds of native ECMAScript objects. Host objects may support these internal properties with any implementation-dependent behavior as long as it is consistent with the specific host object restrictions stated in this document. The value type domain columns of the following tables define the types of values associated with internal properties. The type names refer to the types defined in Clause 8 augmented by the following additional names. Any means the value may be any ECMAScript language type. Primitive means undefined, null, boolean, string, or number. Spec-op means the internal property is an internal method, an implementation provided procedure defined by an abstract operation specification. Spec-op is followed by a list of descriptive ECMA International 2009 31 parameter names. If a parameter name is the same as a type name, then the name describes the type of the parameter. If a spec-op returns a value, Its parameter list is followed by the symbol and the type of the returned value. Internal property, prototype, extensible, get property, put, can put, has property, delete, default value, value type domain, object or null string, boolean, spec ob, property name, any, spec ob, prop, RTY name, undefined or property descriptor, spec ob, property name, undefined or property descriptor, spec ob, property name, any, boolean, spec ob, property name, boolean, spec ob, property name, boolean, spec ob, property name, boolean, boolean, spec ob, hint, primitive spec ob, property name, property descriptor, boolean, Boolean description. The prototype of this object, a string value indicating a specification-defined classification of objects. If true, own properties may be added to the object. Returns the value of the named property. Returns the property descriptor of the named own property of this object, or undefined if absent. Returns the fully populated property descriptor of the named property of this object, or undefined if absent. Sets the specified named property to the value of the second parameter. The flag controls failure handling. Returns a Boolean value indicating whether returns a Boolean value indicating whether the object already has a property with the given name. Removes the specified named own property from the object. The flag controls failure handling. Hint is a string. Returns a default value for the object, creates or alters the named own property to have the state described by a property descriptor. The flag controls failure handling. Table 8. Internal properties common to all objects. Every object, including host objects, must implement all of the internal properties listed in Table 8. However, the internal method may, for some objects, simply throw a type error exception. All objects have an internal property called. The value of this property is either null or an object and is used for implementing inheritance. Whether or not a native object can have a host object as it depends on the implementation. Every chain must have finite length, that is, starting from any object, recursively accessing the internal property must eventually lead to a null value. Named data properties of the object are inherited, are visible as properties of the child object, for the purposes of get access, but not for put access. Named accessor properties are inherited for both get access and put access. Every ECMAScript object has a Boolean valued internal property that controls whether or not named properties may be added to the object. If the value of the internal property is false, then additional named properties may not be added to the object. In addition, if is false, the value of the internal properties of the object may not be modified. Once the value of an internal property has been set to false, it may not be subsequently changed to true. Note this specification defines no ECMAScript language operators or built-in functions that permit a program to modify an object's or internal properties or to change the value of from false to true. 2. Copyright sign. ECMA International 2009. Implementation-specific extensions that modify, or must not violate the invariants defined in the preceding paragraph. The value of the internal property is defined by the specification for every kind of built-in object. The value of the internal property of a host object may be any string value except one of arguments: array, boolean, date, error, function, JSON, math, number, object, regexp, and string. The value of an internal property is used internally to distinguish different kinds of objects. Note that this specification does not provide any means for a program to access that value except through object prototype to string C152442 unless otherwise specified. The common internal methods of native ECMAScript objects behave as described in 8.12. Array objects have a slightly different implementation of the internal method C154551, and string objects have a slightly different implementation of the internal method C155552. Arguments objects 10.6 have different implementations of and function objects 15.3 have a different implementation of. Host objects may implement these internal methods in any manner unless specified otherwise. For example, one possibility is that for a particular host object indeed fetch and store property values but always generates false. However, if any specified manipulation of a host object's internal properties is not supported by an implementation, that manipulation must throw a type error exception when attempted. The internal method of a host object must conform to the following invariants for each property of the host object. If a property is described as a data property and it may return different values over time, then either or both of the and. If a property is described as a data property and its and are both false, then the same value, according to 9.12, must be returned for the attribute of the property on all calls to. If the attributes other than may change over time or if the property might disappear, then the attribute must be true. If the attribute may change from false to true, then the attribute must be true. If the value of the host object's internal property has been observed by ECMAScript code to be false, then if a call to describes a property as non-existent, all subsequent calls must also describe that property as non-existent. The internal method of a host object must not permit the addition of a new property to a host object if the internal property of that host object has been observed by ECMAScript code to be false. If the internal property of that host object has been observed by ECMAScript code to be false, then it must not subsequently become true. ECMA International 2009-33. Internal property value type description domain. Primitive internal state information associated with this object. Of the standard built-in ECMAScript objects, only Boolean, date, number, and string objects implement. Table 9. Internal properties only defined for some objects. Spec op. A list of any object. Creates an object. Invoked via the new operator. The arguments to the spec op. The arguments passed to the new operator. Objects that implement this internal method are called constructors. Spec op. Any. A list of any or reference. Executes code associated with the object. Invoked via a function call expression. The arguments to the spec op are this object and a list containing the arguments passed to the function call expression. Objects that implement this internal method are callable. Only callable objects that are host objects may return reference values. Spec op. Any Boolean returns a Boolean value indicating whether the argument is likely an object that was constructed by this object. Of the standard built-in ECMAScript objects, only function objects implement. Lexical environment. A lexical environment that defines the environment in which a function object is executed. Of the standard built-in ECMAScript objects, only function objects implement. List of strings. A possibly empty list containing the identifier strings of a function's formal parameter list. Of the standard built-in ECMAScript objects, only function objects implement ECMAScript code. The ECMAScript code of a function. Of the standard built-in ECMAScript objects, only function objects implement object. The target function of a function object created using the standard built-in function prototype bind method. Only ECMAScript objects created using function prototype bind have an internal property any. The pre-bound this value of a function object created using the standard built-in function prototype bind method. Only ECMAScript objects created using function prototype bind have an internal property list of any. The pre-bound argument values of a function object created using the standard built-in function prototype bind method. Only ECMAScript objects created using function prototype bind have an internal property spec ob string int x match result tests for a regular expression match and returns a match result value C151021. Of the standard built-in ECMAScript objects, only regexp objects implement object provides a mapping between the properties of an arguments object C10.6 and the formal parameters of the associated function. Only ECMAScript objects that are arguments objects have an internal property 8.7. The reference specification type. The reference type is used to explain the behavior of such operators as delete, type off, and the assignment operators. For example, the left-hand operand of an assignment is expected to produce a 4 copyright sign, ECMA International 2009 reference. The behavior of assignment could, instead, be explained entirely in terms of a case analysis on the syntactic form of the left-hand operand of an assignment operator, but for one difficulty. Function calls are permitted to return references. This possibility is admitted purely for the sake of host objects. No built-in ECMAScript function defined by this specification returns a reference, and there is no provision for a user-defined function to return a reference. Another reason not to use a syntactic case analysis is that it would be lengthy and awkward, affecting many parts of the specification. A reference is a resolved name binding. A reference consists of three components: the base value, the reference name, and the Boolean valued strict reference flag. The base value is either undefined, an object, a Boolean, a string, a number, or an environment record 1 0 2 1. A base value of undefined indicates that the reference could not be resolved to a binding. The reference name is a string. The following abstract operations are used in this specification to access the components of references. GetBase v returns the base value component of the reference v. GetReferenceName v returns the reference name component of the reference v. IsStrictReference v returns the strict reference component of the reference v. Has primitive base v returns true if the base value is a Boolean, string, or number. IsProperty reference v returns true if either the base value is an object or has primitive base v is true, otherwise returns false. Is unresolvable reference v returns true if the base value is undefined and false otherwise. The following abstract operations are used in this specification to operate on references. 7.1 Get value v. If type v is not reference, return v. Let base be the result of calling getBase. v. If is unresolvable reference, v. Throw a reference error exception. If is property reference, v. Then, if his primitive base, v. is false, then let get be the internal method defined PROLOGUE. Return the result of calling the get internal method using base as its this value, and passing get reference name, v. for the argument. Else, base must be an environment record. Return the result of calling the get binding value, C10, 2, 1. Concrete method of base passing, get reference name, v. and is strict reference, v. as arguments. The following, let O be to object, base. Let desc be the result of calling the internal method of O with property name P. If desc is undefined, return undefined. If is data descriptor, desc, is true, return desc. Otherwise, is accessor descriptor, desc, must be true, so let getter be desc. If getter is undefined, return undefined. Return the result calling the internal method of getter providing base as the this value and providing no arguments. Note the object that may be created in step 1 is not accessible outside of the above method. An implementation might choose to avoid the actual creation of the object. The only situation where such an actual property access that uses this internal method can have visible effect is when it invokes an accessor function, 7.2 put value, v, w. If type, v, is not reference, throw a reference error exception. ECMA International 2009-35. 2. Let base be the result of calling get base, v. If is unresolvable reference, v. Then, if is strict reference, v. is true, then I throw reference error exception. Be call there. Else if is property reference, v. Then, if his primitive base, v. is false, then let put be there. Be the special. Be call the put internal method using base as its this value, and passing get reference name, v. for the property name, w. for the value, and is strict reference, v. for the throw flag. Else base must be a reference whose base is an environment record. So, call the set mutable binding, 10, 2, 1. Concrete method of base, passing get reference name, v. w. and is strict reference, v. as arguments. Return the following. Let O be to object, base. If the result of calling the internal method of O with argument P is false, then if throw is true, then throw a type error exception. Be else return. Let ownDesc be the result of calling the internal method of O with argument P. If is data descriptor, ownDesc, is true, then if throw is true, then throw a type error exception. Be else return. Let desc be the result of calling the internal method of O with argument P. This may be either an own or inherited accessor property descriptor or an inherited data property descriptor. If is accessor descriptor, desc, is true, then a let setter be desc. Be call the internal method of setter providing base as the this value in an argument list containing only w. Else, this is a request to create a known property on the transient object O. If throw is true, then throw a type error exception 8. Return. Note the object that may be created in step 1 is not accessible outside of the above method. An implementation might choose to avoid the actual creation of that transient object. The only situations where such an actual property assignment that uses this internal method can have visible effect are when it either invokes an accessor function or is in violation of a throw predicated error check. When throw is true, any property assignment that would create a new property on the transient object throws an error. Point 8. The list specification type. The list type is used to explain the evaluation of argument lists. C1, 1, 2, 4, in new expressions, in function calls, and in other algorithms where a simple list of values is needed. Values of the list type are simply ordered sequences of values. These sequences may be of any length. Point 9. The completion specification type. The completion type is used to explain the behavior of statements break, continue, return and throw that perform non-local transfers of control. Values of the completion type are triples of the form type, value, target, where type is one of normal, break, continue, return, or throw. Value is any ECMAScript language value or empty, and target is any ECMAScript identifier or empty. The term abrupt completion refers to any completion with a type other than normal. 6. Copyright sign. ECMA International 2009. 8.10. The property descriptor and property identifier specification types. The property descriptor type is used to explain the manipulation and reification of named property attributes. Values of the property descriptor type are records composed of named fields where each field's name is an attribute name and its value is a corresponding attribute value as specified in 8.6.1. In addition, any field may be present or absent. Property descriptor values may be further classified as data property descriptors and accessor property descriptors based upon the existence or use of certain fields. A data property descriptor is one that includes any fields named either raw. An accessor property descriptor is one that includes any fields named either. Any property descriptor may have fields named and a property descriptor val. UE may not be both a data property descriptor and an accessor property descriptor. However, it may be neither. A generic property descriptor is a property descriptor value that is neither a data property descriptor nor an accessor property descriptor. A fully populated property descriptor is one that is either an accessor property descriptor or a data property descriptor and that has all of the fields that correspond to the property attributes defined in either 8.6.1 Table 5 or Table 6. For notational convenience within this specification, an object literal-like syntax can be used to define a property descriptor value. For example, property descriptor 42, false, true, defines a data property descriptor. Field name order is not significant. Any fields that are not explicitly listed are considered to be absent. In specification text and algorithms, dot notation may be used to refer to a specific field of a property descriptor. For example, if D is a property descriptor, then D is shorthand for the field of denamed. The property identifier type is used to associate a property name with a property descriptor. Values of the property identifier type are pairs of the form name, descriptor, where name is a string and descriptor is a property descriptor value. The following abstract operations are used in this specification to operate upon property descriptor values. 10.1 is accessor descriptor. Desk. When the abstract operation is accessor descriptor is called with property descriptor desk. The following steps are taken. If desk is undefined, then return false. If both desk are absent, then return false. Return true. 10.2 is data descriptor. Desk. When the abstract operation is data descriptor is called with property descriptor desk. The following steps are taken. If desk is undefined, then return false. If both desk and desk are absent, then return false. Return true. 10.3 is generic descriptor. Desk. When the abstract operation is generic descriptor is called with property descriptor desk. The following steps are taken. If desk is undefined, then return false. If is accessor descriptor, desk, and is data descriptor, desk, are both false, then return true. Return false. ECMA International 2009 37 8 10 4 from property descriptor, desk. When the abstract operation from property descriptor is called with property descriptor desk, the following steps are taken. The following algorithm assumes that desk is a fully populated property descriptor, such as that returned from C8 1 2 1. If desk is undefined, then return undefined. Let obj be the result of creating a new object as if by the expression new object, where object is the standard built-in constructor with that name. If is data descriptor, desk, is true, then call the internal method of obj with arguments value, property descriptor, desk, true, 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 and false. B call the internal method of obj with arguments writable, property descriptor, desk, true, 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 and false. Else is accessor descriptor, desk, must be true. So, call the internal method of obj with arguments get, property descriptor, desk, true, 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 and false. B call the internal method of obj with arguments set, property descriptor, desk, true, 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 and false. Call the internal method of obj with arguments enumerable, property descriptor, desk, true, 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 and false. Call the internal method of obj with arguments configurable, property descriptor, desk, true, 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 and false. Return obj, 10.5 to property descriptor, obj. When the abstract operation to property descriptor is called with object desk, the following steps are taken. If type obj is not object, throw a type error exception. Let desk be the result of creating a new property descriptor that initially has no fields. If the result of calling the internal method of obj with argument enumerable is true, then let enum be the result of calling the b set the field of desk to boolean enum. If the result of calling the internal method of obj with argument configurable is true, then let conf be the result of calling the b set the field of desk to boolean conf. If the result of calling the internal method of obj with argument value is true, then let value be the result of calling the b set the field of desk to value. If the result of calling the internal method of obj with argument writable is true, then let writable be the result of calling the b set the field of desk to boolean writable. If the result of calling the internal method of obj with argument get is true, then let getter be the result of calling the b if is callable. Getter is false and getter is not undefined. Then throw a type error exception. C set the to getter. If the result of calling the internal method of obj with argument set is true, then let setter be the result of calling the b if is callable. Setter is false and setter is not undefined. Then throw a type error exception. C set the if either desk are present, then if either desk or desk are present, then throw a type error exception. 0. Return desk. 8. ECMA International 2009 8.11 The lexical environment and environment record specification types. The lexical environment and environment record types are used to explain the behavior of name resolution in nested functions and blocks. These types and the operations upon them are defined in clause 10.12 algorithms for object internal methods. In the following algorithm descriptions, assume O is a native ECMAScript object, P is a string, desk is a property description record, and throw is a boolean flag, 12.1. P. When the internal method of O is called with property name P, the following steps are taken. If O doesn't have a known property with name P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property named P. If X is a data property, then A set D to the value of X's attribute, B set D to the value of X's attribute. Else X is an accessor property. So, A set D attribute, B set D attribute, set D to the value of X's attribute, set D to the value of X's attribute, return D. However, if O is a string object, it has a more elaborate internal method defined in 1.5.5.2, 12.2. When the internal method of O is called with property name P, the following steps are taken. Let prop be the result of calling the internal method of O with property name P. If prop is not undefined, return prop. Let proto be the value of the internal property of O. If proto is null, return undefined. Return the result of calling the internal method of proto with argument P, 12.3. When the let desk be the result of calling the internal method of O with property name P. If desk is undefined, return undefined. 0. If is data descriptor, desk, is true, return desk. 1. Otherwise, is accessor descriptor, desk, must be true, so let getter be desk. 2. If getter is undefined, return undefined. 3. Return the result calling the internal method of getter providing O a s to this value and providing no arguments. 12.4. P. When the internal method of O is called with property name P, the following steps are taken. Let desk be the result of calling the internal method of O with argument P. If desk is not undefined, then if is accessor descriptor, desk, is true, then ECMA International 2009-39. If desk 2. Else return true, B else. Desk must be a data descriptor, so return the value of desk. Let proto be the internal property of O. If proto is null, then return the value of the internal property of O. Let inherited be the result of calling the internal method of proto with property name P. If inherited is undefined, return the value of the internal property of O. If is accessor descriptor, inherited, is true, then if inherited, B else return true, else. Inherited must be a data descriptor. If the internal property of O is false, return false, B else return the value of inherited. Host objects may define additional constraints upon operations in situations where this definition of returns false, 12.5. When if the result of calling the internal method of O with argument P is false, then if throw is true, then throw a type error exception, B else return. Let own desk be the result of calling the internal method of O with argument P. If is data descriptor, own desk, is true, then a let value desk be the property descriptor. V. Be call the internal method of O passing P, value desk, and throw as arguments. See return. Let desk be the result of calling the internal method of O with argument P. This may be either an own or inherited accessor property descriptor or an inherited data property descriptor. If is accessor descriptor, desk, is true, then a let setter be desk. Be call the internal method of setter providing O as this value and providing V as the sole argument. Else, create a named data property named P on object O as follows. A let new desk be the property descriptor V. True, true, true. Be call the internal method of O passing P, new desk, and throw as arguments. Return, 12.6. P. When the internal method of O is called with property name P, the following steps are taken. Let desk be the result of calling the internal method of O with property name P. If desk is undefined, then return false, else return true, 12.7. P. Throw. When the internal method of O is called with property name P and the boolean flag throw, the following steps are taken. Let desk be the result of calling the internal method of O with property name P. If desk is undefined, then return true. If desk is true, then 0. ECMA International 2009. A. Remove the own property with name P from O. B. Return true. Else if throw, then throw a type error exception. Return false, 12.8. Hint. When the internal method of O is called with hint string, the following steps are taken. Let toString be the result of calling the if is callable toString is true, then a let str be the result of calling the internal method of toString with O as this value in an empty argument list. B. If str is a primitive value, return str. Let value be the result of calling the if is callable value of is true, then a let val be the result of calling the internal method of value of with O as this value in an empty argument list. B. If val is a primitive value, return val. Throw a type error exception. When the internal method of O is called with hint number, The following steps are taken. Let value of be the result of calling the if is callable. Value of is true, then let val be the result of calling the internal method of value of, with O is this value in an empty argument list. B if val is a primitive value, return val. Let to string be the result of calling the if is callable. To string is true, then let str be the result of calling the internal method of to string, with O is this value in an empty argument list. B if str is a primitive value, return str. Throw a type error exception. When the internal method of O is called with no hint, then it behaves as if the hint were number, unless O is a date object, C1596, in which case it behaves as if the hint were string. The above specification of finite objects can return only primitive values. If a host object implements its own internal method, it must ensure that its internal method can return only primitive values. 12.9 p desc throw. In the following algorithm, the term reject means if throw is true, then throw a type error exception, otherwise return false. The algorithm contains steps that test various fields of the property descriptor desc for specific values. The field s that are tested in this manner need not actually exist in desc. If a field is absent, then its value is considered to be false. When the internal method of O is called with property name p, property descriptor desc, and boolean flag throw, the following steps are taken. Let current be the result of calling the internal method of O with property name p. Let extensible be the value of the internal property of O. If current is undefined and extensible is false, then reject. If current is undefined and extensible is true, then if is generic descriptor, desc, or is data descriptor, desc, is true, then I create a known data property named p of object O whose enumerable and attribute values are described by desc. If the value of an attribute field of desc is absent, the attribute of the newly created property is set to its default value. ECMA International 2009 41. B else. Desc must be an accessor property descriptor, so I create an own accessor property named p of object O whose enumerable and attribute values are described by desc. If the value of an attribute field of desc is absent, the attribute of the newly created property is set to its default value. See return true. Return true if every field in desc is absent. Return true if every field in desc also occurs in current and the value of every field in desc is the same value as the corresponding field in current when compared using the same value algorithm. 9.12. If the field of current is false, then A reject. If the field of desc is true, B reject. If the field of desc is present and the fields of current and desc are the Boolean negation of each other, if is generic descriptor, desc, is true, then no further validation is required. Else, if is data descriptor, current, and is data descriptor, desc, have different results, then A reject. If the field of current is false, B if is data descriptor, current, is true, then I convert the property named p of object O from a data property to an accessor property. Preserve the existing values of the converted properties and attributes and set the rest of the properties attributes to their default values. See else. I convert the property named p of object O from an accessor property to a data property. Preserve the existing values of the converted properties and enumerable attributes and set the rest of the properties attributes to their default values. 10. Else. If is data descriptor, current, and is data descriptor, desc, are both true, then if the field of current is false, then I reject. If the field of current is false and the field of desc is true. 2. If the field of current is false, then reject. If the field of desc is present in same value, desc current is false. B else. The field of current is true, so any change is acceptable. 1. Else is accessor descriptor, current, and is accessor descriptor, desc, are both true, so if the field of current is false, then I reject. If the current 2. Reject. If the current 2. For each attribute field of desc that is present, set the correspondingly named attribute of the property named p of object O to the value of the field. 3. Return true. However, if O is an array object, it has a more elaborate internal method defined in 5, 4, 5, 1. Note step 10b allows any field of desc to be different from the corresponding field of current if current's field is true. This even permits changing the of a property whose attribute is false. This is allowed because a true attribute would permit an equivalent sequence of calls where is first set to true, a new is set, and then is set to false. Type conversion and testing. The ECMAScript runtime system performs automatic type conversion as needed. To clarify the semantics of certain constructs, it is useful to define a set of conversion abstract operations. These abstract operations are not a part of the language, They are defined here to aid the specification of the semantics of the language. The conversion abstract operations are polymorphic, that is, they can accept a value of any ECMAScript language type, but not of specification types. 2. Copyright sign. ECMA International 2009 9.1 to primitive. The abstract operation to primitive takes an input argument and an optional argument preferred type. The abstract operation to primitive converts its input argument to a non-object type. If an object is capable of converting to more than one primitive type, it may use the optional hint preferred type to favor that type. Conversion occurs according to Table 10. Input type, undefined null Boolean number string, point 2 to Boolean, Table 10. To primitive conversions. Result. The result equals the input argument no conversion. 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 Object. Return a default value for the object. The default value of an object is retrieved by calling the internal method of the object, passing the optional hint preferred type. The behavior of the internal method is defined by the specification for all native ECMAScript objects in 8.1.2.8. The abstract operation to Boolean converts its argument to a value of type Boolean according to Table 11. Argument type, undefined null Boolean number, string object, point 3 to number, Table 11. To Boolean conversions. The result equals the input argument no conversion. The result is false if the argument is +0, 0, or none. Otherwise the result is true. The result is false if the argument is the empty string. Its length is 0. Otherwise the result is true. True. Result. False. False. The abstract operation to number converts its argument to a value of type number according to Table 12. ECMA International 2009 43. Argument type, undefined null Boolean, number string object. Table 12. To number conversions. Result, none +0. The result is 1 if the argument is true. The result is +0 if the argument is false. The result equals the input argument no conversion. See grammar note below. Apply the following steps. Let prim value be to primitive. Input argument. Hint number. Return to number. Prim value. 9, 3, 1. To number applied to the string type. To number applied to strings applies the following grammar to the input string. If the grammar cannot interpret the string as an expansion of string numeric literal, then the result of to number is nan, string numeric literal, str white spaciat, str white spaciat, str numeric literal, str white spaciat, str white space char, str white spaciat, str white space char, white space, line terminator, str numeric literal, str decimal literal hex integer literal, str decimal literal, str unsigned decimal literal, str unsigned decimal literal, str unsigned decimal literal, str unsigned decimal literal, infinity decimal digits. Decimal digits opt exponent part opt. Decimal digits exponent part opt. Decimal digits exponent part opt. Decimal digits. Decimal digit. Decimal digits. Decimal digit. Decimal digit. 1 of 123,456,789. Exponent part. Exponent indicator signed integer. Exponent indicator. 1 of EE. 4. ECMA International 2009. Signed integer. Decimal digits. Decimal digits. Decimal digits. Hex integer literal. 0x hex digit 0x hex digit. Hex integer literal hex digit. 1 of 0 1 2 3 4 5 6 7 8 9 abdef abcdef. Some differences should be noted between the syntax of a string numeric literal and a numeric literal. C7, 8, 3. A string numeric literal may be preceded and or followed by white space and or line terminators. A string numeric literal that is decimal may have any number of leading 0 digits. A string numeric literal that is decimal may be preceded by plus or to indicate its sign. A string numeric literal that is empty or contains only white space is converted to +0. The conversion of a string to a number value is similar overall to the determination of the number value for a numeric literal. C7, 8, 3. But some of the details are different. So the process for converting a string numeric literal to a value of number type is given here in full. This value is determined in 2 steps. First, MR, thematical value, MV, is derived from the string numeric literal. Second, this mathematical value is rounded as described below. The MV of string numeric literal, empty, is 0. The MV of string numeric literal, str white space is 0. The MV of string numeric literal, str white spaciat, str numeric literal, str white spaciat is the MV of str numeric literal. no matter whether white space is present or not. The MV of str numeric literal. Str decimal literal is the MV of str decimal literal. The MV of str numeric literal. Hex integer literal is the MV of hex integer literal. The MV of str decimal literal. str unsigned decimal literal is the MV of str unsigned decimal literal. The MV of str decimal literal plus str unsigned decimal literal is the MV of str unsigned decimal literal. The MV of str decimal literal. str unsigned decimal literal is the negative of the MV of str unsigned decimal literal. Note that if the MV of str unsigned decimal literal is 0, the negative of this MV is also 0. The rounding rule described below handles the conversion of this signless mathematical 0 to a floating point plus 0 or 0 as appropriate. The MV of str unsigned decimal literal. Infinity is 1,010,000, a value so large that it will round to plus. The MV of str unsigned decimal literal. Decimal digits is the MV of decimal digits. The MV of str unsigned decimal literal. Decimal digits. Decimal digits is the MV of the first decimal digits, plus the MV of the second decimal digits times 10n, where n is the number of characters in the second decimal digits. The MV of str unsigned decimal literal. Decimal digits. Exponent part is the MV of decimal digits times 10e, where e is the MV of exponent part. The MV of str unsigned decimal literal. Decimal digits. Decimal digits exponent part is the MV of the first decimal digits plus the MV of the second decimal digits times 10n times 10e, where n is the number of characters in the second decimal digits and e is the MV of exponent part. The MV of str unsigned decimal literal. Decimal digits is the MV of decimal digits times 10n, where n is the number of characters in decimal digits. The MV of str unsigned decimal literal. Decimal digits exponent part is the MV of decimal digits times 10n, where n is the number of characters in decimal digits and e is the MV of exponent part. The MV of str unsigned decimal literal. Decimal digits is the MV of decimal digits. The MV of str unsigned decimal literal. Decimal digits exponent part is the MV of decimal digits times 10e, where e is the MV of exponent part. The MV of decimal digits. Decimal digit is the MV of decimal digit. ECMA International 2009 45, the MV of decimal digits. Decimal digits decimal digit is the MV of decimal digits times 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the MV of decimal digits. The MV of signed integer plus decimal digits is the MV of decimal digits. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 is 0. The MV of decimal digit. 1 or of hex digit. 1 is 1. The MV of decimal digit. 2 or of hex digit. 2 is 2. The MV of decimal digit. 3 or of hex digit. 3 is 3. The MV of decimal digit. 4 or of hex digit. 4 is 4. The MV of decimal digit. 5 or of hex digit. 5 is 5. The MV of decimal digit. 6 or of hex digit. 6 is 6. The MV of decimal digit. 7 or of hex digit. 7 is 7. The MV of decimal digit. 8 or of hex digit. 8 is 8. The MV of decimal digit. 9 or of hex digit. 9 is 9. The MV of hex digit. A or of hex digit. A is 10. The MV of hex digit. B or of hex digit. B is 11. The MV of hex digit. C or of hex digit. C is 12. The MV of hex digit. D or of hex digit. D is 13. The MV of hex digit. E or of hex digit. E is 14. The MV of hex digit. F or of hex digit. F is 15. The MV of hex integer literal. 0x hex digit is the MV of hex digit. The MV of hex integer literal. 0x hex digit is the MV of hex digit. The MV of hex integer literal. Hex integer literal hex digit is the MV of hex integer literal times 16 plus the MV of hex digit. Once the exact MV for a string numeric literal has been determined, it is then rounded to a value of the number type. If the MV is 0, then the rounded value is plus 0 unless the first non-white space character in the string numeric literal is comma, in which case the rounded value is 0. Otherwise, the rounded value must be the number value for the MV, in the sense defined in 8.5, unless the literal includes str unsigned decimal literal and the literal has more than 20 significant digits. in which case the number value may be either the number value for the MV of a literal produced by replacing each significant digit after the 20th with a 0 digit, or the number value for the MV of a literal produced by replacing each significant digit after the 20th with a 0 digit and then incrementing the literal at the 20th digit position. A digit is significant if it is not part of an exponent part and it is not 0, or there is a non-zero digit to its left and there is a non-zero digit not in the exponent part to its right. Point 4 to integer. The abstract operation to integer converts its argument to an integral numeric value. This abstract operation functions as follows. Let number be the result of calling to number on the input argument. If number is nan, return +0. If number is +0, 0, plus, or return number. Return the result of computing sign, number, floor, abs, number. Point 5 to int32. Sign 32-bit integer. The abstract operation to int32 converts its argument to one of 232 integer values in the range 231 through 231 1, inclusive. This abstract operation functions as follows. 6. Copyright sign, ECMA International 2009. 1. Let number be the result of calling to number O and the input argument. If number is nan, +0, 0, plus, or return +0. Let pose int be sign, number, floor, abs, number. Let int 32-bit be pose int modulo 232. That is, a finite integer value k of number type with positive sign and less than 232 in magnitude such that the mathematical difference of pose int and k is mathematically an integer multiple of 232. If int 32-bit is greater than or equal to 231, return int 32-bit 232. Otherwise return int 32-bit. Note: given the above definition of toint32, the toint32 abstract operation is idempotent. If applied to a result that it produced, the second application leaves that value unchanged. Toint32, toint32, x is equal to toint32, x. For all values of x, it is to preserve this latter property that plus and a mapped to +0. To int 32 maps 0 to +0. Point 6 toint32, unsigned 32-bit integer. The abstract operation toint32 converts its argument to one of 232 integer values in the range 0 through 232 1, inclusive. This abstraction operation functions as follows. Let number be the result of calling to number on the input argument. If number is nan, +0, 0, plus, or return +0. Let pose int be sign, number, floor, abs, number. Let int 32-bit be pose int modulo 232. That is, a finite integer value k of number type with positive sign and less than 232 in magnitude such that the mathematical difference of pose int and k is mathematically an integer multiple of 232. Return int 32-bit. Note: given the above definition of tau int 32, step 5 is the only difference between toint32 and toint32. The toint32 abstract operation is idempotent. If applied to a result that it produced, the second application leaves that value unchanged. Toint32, toint32, x is equal to toint32, x. For all values of x, it is to preserve this latter property that plus and are mapped to +0. Toint32 maps 0 to +0. Point 7 toint16, unsigned 16-bit integer. The abstract operation toint16 converts its argument to one of 216 integer values in the range 0 through 216 1, inclusive. This abstract operation functions as follows. Let number be the result of calling to number on the input argument. If number is nan, +0, 0, plus, or return +0. Let pose int be sign, number, floor, abs, number. Let int 16-bit be pose int modulo 216. That is, a finite integer value k of number type with positive sign and less than 216 in magnitude such that the mathematical difference of pose int and k is mathematically an integer multiple of 216. Return int 16-bit. Note: given the above definition of toint16, the substitution of 216 for 232 in step 4 is the only difference between toint32 and toint16. Toint16 maps 0 to +0, 9.8 to string. The abstract operation to string converts its argument to a value of type string according to table 13. ECMA International 2009 47. Argument type undefined null boolean number string object. Table 13. To string conversions. Undefined null. If the argument is true, then the result is true. If the argument is false, then the result is false. C9, 8, 1. Return the input argument no conversion. Apply the following steps. Let prim value be to primitive. Input argument. Hint string 2. Return to string. Prim value. Result. 9, 8, 1 to string applied to the number type. The abstract operation to string converts a number m to string format as follows. If m is nan, return the string nan. If m is plus 0 or 0, return the string 0. If m is less than 0, return the string concatenation of the string into string m. If m is infinity, return the string infinity. Otherwise, let n, k, and s be integers such that k1, 10k1s, 10k, the number value for S10 and k is m, and k is as small as possible. Note that k is the number of digits in the decimal representation of s, that s is not divisible by 10, and that the least significant digit of s is not necessarily uniquely determined by these criteria. If k and 21, return the string consisting of the k digits of the decimal representation of s, in order, with no leading zeros, followed by nk occurrences of the character 0. If 0, n21, return the string consisting of the most significant n digits of the decimal representation of s, followed by a decimal point, followed by the remaining k n digits of the decimal representation of s. If 6, n0, return the string consisting of the character 0, followed by a decimal point, followed by n occurrences of the character 0, followed by the k digits of the decimal representation of s. Otherwise, if k equals 1, return the string consisting of the single digit of s, followed by lowercase character e, followed by a plus or minus sign according to whether n1 is positive or negative, followed by the decimal representation of the integer abs, n1, with no leading zeros, 0, return the string consisting of the most significant digit of the decimal representation of s, followed by a decimal point, followed by the remaining k1 digits of the decimal representation of s, followed by the lowercase character e, followed by a plus or minus sign according to whether n1 is positive or negative, followed by the decimal representation of the integer abs, n1, with no leading zeros. Note 1. The following observations may be useful as guidelines for implementations, but are not part of the normative requirements of this standard. If x is any number value other than 0, then to string, x, is exactly the same number value as x. The least significant digit of s is not always uniquely determined by the requirements listed in step 5. Note 2. For implementations that provide more accurate conversions than required by the rules above, it is recommended that the following alternative version of step 5 be used as a guideline. Otherwise, let n, k, and spinteger such that 1, 10k1s, 10k, the number value for 10nk is m, and k is as small as possible. If there are multiple possibilities for s, choose the value of s for which s10nk is closest in value to m. If there are 2 such possible values of s, choose the one that is even. Note that k is the number of digits in the decimal representation of s and that s is not divisible by 10. Note 3. Implementers of ECMAScript may find useful the paper and code written by David M. Gay for binary to decimal conversion of floating point numbers. 8. Copyright sign, ECMA International 2009. Gay, David M. Correctly rounded binary decimal and decimal binary conversions. Numerical analysis, Manuscript 9010. AT&T Bell Laboratories, Murray Hill, New Jersey. The 30th of November, 1990. Available as http://cm.bell-labs.com/cm/cs/doc/90/4-10.ps.gz. Associated code available as http://cm.bell-labs.com/netlib/fp/dtour.c.gz and as http://cm.bell-labs.com/netlib/fp/g_fmt.c.gz and may also be found at the various netlib mirror sites. Point 9. To object. The abstract operation to object converts its argument to a value of type object according to table 14. Argument type, undefined null boolean, number, string object. Result, table 14. To object. Throw a type error exception. Throw a type error exception. Create a new boolean object whose internal property is set to the value of the argument. See 15.6 for a description of boolean objects. Create a new number object whose internal property is set to the value of the argument. See 15.7 for a description of number objects. Create a new string object whose internal property is set to the value of the argument. See 15.5 for a description of string objects. The result is the input argument no
I totally forgot
abstract operation check object coercible throws an error if its argument
that I'm making a 4-bit value to 8-bit. So I've been shifting 4 bits. After I said it, I'm like, what the hell is going on? Is it because it's 64-bit register? Dang it. I'll get back to this. I just wasted so much time. I thought it had something to do because, like, if you set a 32-bit register, they like clear out the top bits or something. There's all these stupid rules. So I thought that's what it was. And I'm like, oh, wait a second. It's a byte. It's not 4 bits. I'll BRB. Dang it. Such a waste of time.
return false if type x is undefined. Return true if type x is null. Return true if type x is number. Then, if x is nan and y is nan, return true. B if x is plus 0 and y is minus 0, return false. C if x is minus 0 and y is plus 0, return false. D if x is the same number value as y, return true. E return false. If type x is string, then return true if x and y are exactly the same sequence of characters, same length and same characters in corresponding positions. Otherwise, return false. If type x is Boolean, return true if x and y are both true or both false. Otherwise, return false. Return true if x and y refer to the same object. Otherwise, return false. 0 Executable code and execution contexts. 0.1 Types of executable code. There are 3 types of ECMAScript executable code. Global code is source text that is treated as an ECMAScript program. The global code of a particular program does not include any source text that is passed as part of a function body. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript program. The eval code for a particular invocation of eval is the global code portion of that program. Function code is source text that is passed as part of a function body. The function code of a particular function body does not include any source text that is passed as part of a nested function body. Function code also denotes the source text supplied when using the built-in function object as a constructor. More precisely, the last parameter provided to the function constructor is converted to a string and treated as the function body. If more than one parameter is provided to the function constructor, all parameters except the last one are converted to strings and concatenated together, separated by commas. The resulting string is interpreted as the formal parameter list for the function body defined by the last parameter. The function code for a particular instantiation of a function does not include any source text that is passed as part of a nested function body. 0 ECMA International 2009 101 1 Strict mode code. An ECMAScript program syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. When processed using strict mode, the 3 types of ECMAScript code are referred to as strict global code, strict eval code, and strict function code. Code is interpreted as strict mode code in the following situations. Global code is strict global code if it begins with a directive prologue that contains a use strict directive, see 14.1. Eval code is strict eval code if it begins with a directive prologue that contains a use strict directive or if the call to eval is a direct call, see 15. 1. 2. 1. 1. To the eval function that is contained in strict mode code. Function code that is part of a function declaration, function expression, or accessor property assignment is strict function code if its function declaration, function expression, or property is. Assignment is contained in strict mode code or if the function code begins with a directive prologue that contains a use strict directive. Function code that is supplied as the last argument to the built in function constructor is strict function code if the last argument is a string that, when processed as a function body, begins with a directive prologue that contains a use strict directive. 0.2 Lexical environments. A lexical environment is a specification type used to define the association of identifiers to specific variables and functions based upon the lexical nesting structure of ECMAScript code. A lexical environment consists of an environment record and a possibly null reference to an outer lexical environment. Usually a lexical environment is associated with some specific syntactic structure of ECMAScript code, such as a function declaration, a with statement, or a catch clause of a try statement, and a new lexical environment is created each time such code is evaluated. An environment record records the identifier bindings that are created within the scope of its associated lexical environment. The outer environment reference is used to model the logical nesting of lexical environment values. The outer reference of a inner lexical environment is a reference to the lexical environment that logically surrounds the inner lexical environment. An outer lexical environment may, of course, have its own outer lexical environment. A lexical environment may serve as the outer environment for multiple inner lexical environments. For example, if a function declaration contains two nested function declarations, then the lexical environments of each of the nested functions will have as their outer lexical environment the lexical environment of the current execution of the surrounding function. Lexical environments and environment record values are purely specification mechanisms and need not correspond to any specific artifact of an ECMAScript implementation. It is impossible for an ECMAScript program to directly access or manipulate such values. 0, 2, 1 environment records. There are two kinds of environment record values used in this specification: declarative environment records and object environment records. Declarative environment records are used to define the effect of ECMAScript language syntactic elements such as function declarations, variable declarations, and catch clauses that directly associate identifier bindings with ECMAScript language values. Object environment records are used to define the effect of ECMAScript elements such as program and with statement that associate identifier bindings with the properties of some object. For specification purposes, environment record values can be thought of as existing in a simple, object-oriented hierarchy where environment record is an abstract class with two concrete subclasses: declarative environment record and object environment record. The abstract class includes the abstract specification, ECMA International 2009-51, methods defined in Table 17. These abstract methods have distinct concrete algorithms for each of the concrete subclasses. Method has binding. N. Table 17. Abstract methods of environment records. Purpose: determine if an environment record has a binding for an identifier. Return true if it does and false if it does not. The string value n is the text of the identifier. Create mutable binding. N. D. Create a new mutable binding in an environment record. The string value n is the text of the bound name. If the optional Boolean argument d is true, the binding is may be subsequently deleted. Set mutable binding. N. V. S. Set the value of an already existing mutable binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and may be a value of any ECMAScript language type. S is a Boolean flag. If S is true and the binding cannot be set, throw a type error exception. S is used to identify strict mode references. Get binding value, N. S, returns the value of an already existing binding from an environment record. The string value n is the text of the bound name. S is used to identify strict mode references. If S is true and the binding does not exist or is uninitialized, throw a reference error exception. Delete binding. N. Delete a binding from an environment record. The string value n is the text of the bound name. If a binding for n exists, remove the binding and return true. If the binding exists but cannot be removed, return false. If the binding does not exist, return true. Implicit this value returns the value to use as the this value on calls to function objects that are obtained as binding values from this environment record. 1 0, 2, 1, 1. Declarative environment records. Each declarative environment record is associated with an ECMAScript program scope containing variable and/or function declarations. A declarative environment record binds the set of identifiers defined by the declarations contained within its scope. In addition to the mutable bindings supported by all environment records, declarative environment records also provide for immutable bindings. An immutable binding is one where the association between an identifier and a value may not be modified once it has been established. Creation and initialization of immutable binding are distinct steps, so it is possible for such bindings to exist in either an initialized or uninitialized state. Declarative environment records support the methods listed in Table 18 in addition to the environment record abstract specification methods. Table 18. Additional methods of declarative environment records. Method, create immutable binding. N, purpose, create a new but uninitialized immutable binding in an environment record. The string value n is the text of the bound name. Initialize immutable binding. N, v, set the value of an already existing but uninitialized immutable binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and is a value of any ECMAScript language type. 52. ECMA International 2009. The behavior of the concrete specification methods for declarative environment records are defined by the following algorithms. 0, 2, 1, 1. 1 has binding. N. The concrete environment record method has binding for declarative environment records simply determines if the argument identifier is one of the identifiers bound by the record. Let envrec be the declarative environment record for which the method was invoked. If envrec has a binding for the name, that is the value of n. Return true. If it does not have such a binding, return false. 0, 2, 1, 1. 2. Create mutable binding. N. D. The concrete environment record method create mutable binding for declarative environment records creates a new mutable binding for the name and that is initialized to the value undefined. A binding must not already exist in this environment record for an if Boolean argument D is provided and has the value true, the new binding is marked as being subject to deletion. Let envrec be the declarative environment record for which the method was invoked. Assert envrec does not already have a binding for n. Create a mutable binding in envrec for n and set its bound value to undefined. If D is true, record that the newly created binding may be deleted by a subsequent delete binding call. 0, 2, 1, 1. 3. Set mutable binding. N, V, S. The concrete environment record method set mutable binding for declarative environment records attempts to change the bound value of the current binding of the identifier whose name is the value of the argument n to the value of argument va binding. For n must already exist. If the binding is an immutable binding, a type error is always thrown. The S argument is ignored because strict mode does not change the meaning of setting bindings in declarative environment records. Let envrec be the declarative environment record for which the method was invoked. Assert envrec must have a binding for n. If the binding for n in envrec is a mutable binding, change its bound value to v, else this must be an attempt to change the value of an immutable binding, so throw a type error exception. 0, 2, 1, 1. 4. Get binding value. N, S. The concrete environment record method get binding value for declarative environment records simply returns the value of its bound identifier whose name is the value of the argument and the binding must already exist. If S is true and the binding is an uninitialized immutable binding, throw a reference error exception. Let envrec be the declarative environment record for which the method was invoked. Assert envrec has a binding for n. If the binding for n in envrec is an uninitialized immutable binding, then if S is false, return the value undefined. Otherwise throw a reference error exception for else. Return the value currently bound to n in envrec. 0, 2, 1, 1. 5. Delete binding. N. The concrete environment record method delete binding for declarative environment records can only delete bindings that have been explicitly designated as being subject to deletion. Let envrec be the declarative environment record for which the method was invoked. If envrec does not have a binding for the name, that is the value of n, return true. If the binding for n in envrec is cannot be deleted, return false. ECMA International 2009 53. 4. Remove the binding for n from envrec.
Testing, testing. Test, test.
Value of x's attribute. Set d to the value of x's attribute. Return d 0, 1, 6, p, desk. The internal method of an ordinary object O takes arguments p, a property key, and desk, a property descriptor. And or throw complete steps when called. Return. Ordinary define known property. O, p, desk 1.
There's 4 bits in a nibble. And then there's 1 byte in a jar code. And I was thinking, I'm gonna like shift it 4 bits, print it, then shift it 4 more bits, print it, shift it, or whatever. And then it's like, something's wrong. I'll rotate the bits. And after like way too long, I'm like, oh yeah, there's 8 bits in a byte, not 4. So I gotta like, I don't know. That was annoying. So now I'm gonna like type it up and actually make progress. That sucked. So now I'm gonna like account for the fact that each jar code is 8 bits, not 4 bits. And I should be okay, and it's gonna work. That was really annoying. I was like, what the hell is going on? And now I realized, oh, that was it. I don't know, that was a extremely boring story.
L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible, desk, current 1016.
The xlat instruction, whatever, is like a old, I'll call it, CPU instruction. You'd set like the DS segment, or I think you could like override it with another segment if you put it in the address access, whatever it's called, the braces, the square ones, brackets.
Extensible.
And you use like EBX with it to hold the base, and then the AL register
E, capital A,
is passed in to
P, P, L, Y,
the address that EBX or BX, whatever holds.
T,
But it was segmented memory for the older whatever. So it'd be like DS with EBX or BX or whatever it was.
P, a property key, extensible.
So like whatever AL holds is what it's gonna fetch from the address. So it's a nibble. So I gotta like mask it, get 4 bits, and I'll get 0 to 16. And it's that simple. I could use a move, but I'm gonna do this because I can. And it's funky. And it works, so I'm gonna try it. Because they still support it. So I don't know. I'm using xlat instead of move. Because I can.
Desk is true. Then, I create an own accessor property named P of object O whose, and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. Else, I create a known data property named P of object O whose, and configurable attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value, otherwise you return true. Assert. Current is a fully populated property descriptor. If desk does not have any fields, return true. If current is false, then 70. ECMA International 2024. ABC. If desk has a field and desk is true, return false. If desk has an field and desk is not current, return false. If is generic descriptor, desk, is false and is accessor descriptor. Desk is not is accessor descriptor. Current, return false. Def is accessor descriptor. Current is true. Then, if desk has a current 2. If desk has a current, else if current is false, then, if desk has a field and desk is true, return false 2. If desk has a field and same value, desk, current, is false, return false. If O is not undefined, then, if is data descriptor, current, is true and is accessor descriptor, desk, is true. Then, if desk has a field, let configurable be desk, else let configurable be current 2. If desk has a field, let enumerable be desk, else let enumerable be current 3. Replace the property named P of object O with an accessor property whose and attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. B else if is accessor descriptor, current, is true and is data descriptor, desk, is true. Then, if desk has a field, let configurable be desk, else let configurable be current 2. If desk has a field, let enumerable be desk, else let enumerable be current 3. Replace the property named P of object O with a data property whose and enumerable attributes are set to configurable and enumerable, respectively, and whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. See else. For each field of desk, set the corresponding attribute of the property named P of object O to the value of the field 7. Return true 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return. Ordinary has property O, P, 0, 1, 7, 1. Ordinary has property O, P. The abstract operation ordinary has property takes argument so, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let has own be O, P. If his own is not undefined, return true. Let parent be O. If parent is not null, then a return parent. P5. Return false 0, 1, 8. The return ordinary get O, P. Receiver ECMA International 2024 171 10 1 8 1. Ordinary get O, P. Receiver. The abstract operation ordinary get takes argument so, an object, P, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let desk be O, P. If desk is undefined, then a let parent be O, B. If parent is null, return undefined. C. Return parent. If is data descriptor, desk, is true, return desk. Assert is accessor descriptor, desk, is true. Let getter be desk. If getter is undefined, return undefined. Return call getter receiver 0, 1, 9. The return ordinary set O, P, V. Receiver 1, 0, 1, 9, 1. Ordinary set O, P, V. Receiver. The abstract operation ordinary set takes argument so, an object, P, a property key, V, an ECMAScript language value, and receiver, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let own desk be O, P. Return ordinary set with own descriptor O, P, V. Receiver, own desk 0, 1, 9, 2. Ordinary set with own descriptor O, P, V. Receiver, own desk. The abstract operation ordinary set with own descriptor takes argument so, an object, P, a property key, V, an ECMAScript language value, receiver, an ECMAScript language value, and own desk, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If own desk is undefined, then a let parent be O, B. If parent is not null, then I return parent. I set own desk to the property descriptor, undefined, true, true, true. If is data descriptor, own desk, is true, Then, 72. ECMA International 2024. ABCD. E. If ownDesk is false, return false. If receiver is not an object, re2. RN false. Let existing descriptor be receiver, P. If existing descriptor is not undefined, then I if is accessor descriptor, existing descriptor, is true, return false. 2. If existing descriptor is false, return false. 3. Let value desk be the property descriptor, V. If return receiver, P. Value desk, else I assert receiver does not currently have a property P. 2. Return create data property, receiver, P. V. Assert is accessor descriptor, ownDesk is true. Let setter be ownDesk. If setter is undefined, return false. Perform call setter receiver, V. Return true. 0 1 1 0 P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary delete O P 10 1 10 1 ordinary delete O P. The abstract operation ordinary delete takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let desk be O P. If desk is undefined, return true. If desk is true, then A remove the own property with name P from O. B return true. Return false. 0 1 1 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Return ordinary own property keys, O 10 1 1 1 1 ordinary own property keys, O. The abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called. Let keys be a new empty list. For each own property key P of O such that P is an array index, in ascending numeric index order, do A append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do A append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do A append P to keys. 5. Return keys 0 1 1 2 ordinary object create proto additional internal slots list. The abstract operation ordinary object create takes argument proto an object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal slots. ECMA International 2024 173. That must be defined as part of the object. Beyond and. If additional internal slots list is not provided, a new empty list is used. It performs the following steps when called. Let internal slots list be. If additional internal slots list is present, set internal slots list to the list concatenation of internal slots list and additional internal slots list. Let O be make basic object. Internal slots list. Set O to proto. Return O. 0 1 1 3 ordinary create from constructor. Constructor. Intrinsic default proto. Internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get prototype from constructor. Constructor, intrinsic default proto. If internal slots list is present, let slots list be internal slots list. Else, let slots list be a new empty list. Return ordinary object create. Proto, slots list. 0 1 1 4 get prototype from constructor. Constructor, intrinsic default proto. The abstract operation get prototype from constructor takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get. Constructor. Prototype. If proto is not an object, then let realm be. Get function realm. Constructor. B set proto to realm's intrinsic object named intrinsic default proto. Return proto. Note, although ordinary object create does little more than call make basic object, its use communicates the intention to create an ordinary object, and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make basic object directly. 174 ECMA International 2024. Note, if constructor does not supply a value, the default value that is used is obtained from the realm of the constructor function rather than from the running execution context. The 10th of January 2015 require internal slot. Internal slot. The abstract operation require internal slot takes arguments an ECMAScript language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMAScript function objects. ECMAScript function objects encapsulate parameterized ECMAScript code closed over a lexical environment and support the dynamic evaluation of the code. An ECMAScript function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMAScript function object may be either strict mode code, 1122, or non-strict code. An ECMAScript function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to an ECMAScript function objects also have the internal slots listed in Table 30. Table 30. Internal slots of ECMAScript function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMAScript code. A parse node. The root parse node of the source text that defines the function's body. Construct kind. Base or derived. Whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module. A script record or a module record. The script or module in which the function was created. This mode, lexical, strict, or global, defines how this references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. CT means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object, and any other this value is first passed to object. Copyright sign, ECMA International 2024, 75. Table 30, internal slots of ECMAScript function objects. Continued. Internal slot. Type. Description. Strict. A boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class, this is a list representing the non-static private methods and accessors of the class. Class field initializer name. A string. A symbol. A private name. or empty. If the function is created as the initializer of a class field, the name to use for named evaluation of the field, empty otherwise, is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMAScript function objects have the internal method defined here. ECMAScript functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list. The internal method of an ECMAScript function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If F is true, then a let error be a newly created type error object. B note. Error is created in callee context with F's associated realm record. C. Remove callee context from the execution context stack and restore caller context as the running execution context. D. Return throw completion. Error. Perform ordinary call binds this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return of abrupt. Result 0. Return undefined. 176. ECMA International 2024. Note where callee context is removed from the execution context stack in step 7, it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 10, 2, 1. 1. Prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments f, an ECMAScript function object, a new target, an object or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMAScript code execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to f. Let local env be new function environment. F. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env. 0. Set the private environment of callee context to f1. If caller context is not already suspended, suspend caller context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note. Any exception objects produced after this point are associated with callee realm. 4. Return callee context. 0, 2, 1. 2. Ordinary call binds this. F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments f, an ECMAScript function object, callee context, an execution context, and this argument, an ECMAScript language value, and returns unused. It performs the following steps when called. Let this mode be f. If this mode is lexical, return unused. Let callee realm be f. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument 6. Else, if this argument is either undefined or null, then I let global env be callee realm 2. Assert. Global env is a global environment record. 3. Let this value be global env. Be else, I let this value be. To object, this argument. 2. Note. To object produces wrapper objects using callee realm. Assert. Local env is a function environment record. Assert. The next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value. 0. Return unused. 0, 2, 1. 3. Runtime semantics. Evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over following productions. Function body. Function statement list. Return. Evaluate function body of function body with arguments function object and arguments list. Concise body. Expression body. Return. Evaluate concise body with arguments function object and arguments list. ECMA International 2024 177. Generator body. Function body. Return. Evaluate generator body with arguments function object and arguments list. Async generator body. Function body. Return. Evaluate async generator body with arguments function object and arguments list. Async function body. Function body. Return. Evaluate async function body with arguments function object and arguments list. Async concise body. Expression body. Return. Evaluate async concise body with arguments function object and arguments list. Initializer assignment expression assert. Arguments list is empty. Assert. Function object is not empty. If is anonymous function definition assignment expression is true, then a let value be. Named evaluation of initializer with argument function object, else a let RHS be. Evaluation of assignment expression be let value be. Get value, RHS, return completion record, return, value, empty, class static block body, class static block statement list, assert, arguments list is empty, return. Evaluate class static block body with argument function object, 0, 2, 1. For ordinary call evaluate body, F, arguments list. The abstract operation ordinary call evaluate body takes arguments F, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of F with arguments F and arguments list 1, 0, 2, 2. Arguments list. New target. The internal method of an ECMAScript function object F takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be F if kind is base, then a let this argument be. Ordinary create from constructor. New target. %object prototype %4. Let callee context be prepare for ordinary call. F. New target. 178. ECMA International 2024. Note even though field initializers constitute a function boundary, calling capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this. F. Callee context. This argument be let initialize result be completion, initialize instance elements. This argument, F, see if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion, ordinary call evaluate body, F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then if result is an object, return result. B if kind is base, return this argument. C if result is not undefined, throw a type error exception. 1. Else a return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0, 2, 3 ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body a parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null. And returns an ECMAScript function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method. although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specified in 1.0.2. 1. Set f to source text. Set f to parameter list. Set f to body. If the source text matched by body is strict mode code, let strict be true, else let strict be false. Set f to strict. If this mode is lexical, set f to lexical 0, else if strict is true, set f to strict 1, else set f to global 2, set f to false 3, set f to env 4, set f to private env 5, set f to get active script or module 6, set f to the current realm record 7, set f to undefined 8, set f to a new empty list 9, set f to a new empty list 0, set f to empty 1. Let len be the expected argument counter parameter list 2. Perform set function length f len 3. Return f ECMA International 2024 179 102 4 capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E F realm. The abstract operation capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E takes arguments f, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert realm exists and has been initialized. Let thrower be realm. Perform define property or throw f caller property descriptor thrower enumerable false true. Perform define property or throw f arguments property descriptor thrower enumerable false true. Return unused 0 2 4 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0 2 5 make constructor f writable prototype prototype. The abstract operation make constructor takes argument f, an ECMAScript function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMAScript function object, then a assert is constructor, f is false. B assert f is an extensible object that does not have a prototype own property. C set f to the definition specified in 1.0.2. 2. Else a set f to the definition specified in 1.0.3. 2. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create. %object prototype %. B perform define property or throw prototype constructor property descriptor f writable prototype false true. Perform define property or throw f prototype property descriptor prototype writable prototype false false. Return unused. 80 ECMA International 2024 1.0.2. 6 make class constructor f. The abstract operation make class constructor takes argument f, an ECMAScript function object, and returns unused. It performs the following steps when called. Assert f is false. Set f to true. Return unused. 0 2 7 make method f home object. The abstract operation make method takes arguments f, an ECMAScript function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object, return unused, 0, 2, 8 define method property, home object, key, closure, enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert. Home object is an ordinary, extensible object if key is a private name, then a return private element. Method. Closure 3. Else, a let desk be the property descriptor. Closure. True. Enumerable. True. Be perform. Define property or throw. Home object. Key. Desk. C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9 set function name. F. Name. Prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description, and else if name is a private name. Then a set name to name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f has an internal slot, then optionally set f to name. Perform. Define property or throw f. Name. Property descriptor. Name. False. Enumerable. False. True. Return unused. ECMA International 2024 181. The 10th of February 2010. Set function length. F. Length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw f. Length. Property descriptor. Length. False. Enumerable. False. True. Return unused. 0, 2, 1, 1. Capital F. U. N. C. T. I. O. N. Capital D. E. C. L. A. R. A. T. I. O. N. Capital I. N. S. T. A. N. T. I. A. T. I. Func. Arguments list. The abstract operation. Capital F. U. N. C. T. I. O. N. Capital D. E. C. L. A. R. A. T. I. O. N. Capital I. N. S. T. A. N. T. I. A. T. I. Takes arguments func, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for WIC. H. The execution context is being established. Note 1. When an execution context is established for evaluating an ECMAScript function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor a binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note, arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then if function names contains arguments or lexical names contains arguments, then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then a note, only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B let env be the lexical environment of callee context. 0. Else a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment, callee env. D assert, the variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared benv has binding. Param name, b note, early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then, I perform env create mutable binding. Param name, false. 2. If his duplicates is true, then perform env initialize binding. Param name, undefined 22. If arguments object needed is true, then if strict is true or simple parameter list is false, then I let AOB create a mapped arguments object, arguments list. B else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env. See if strict is true, then I perform env create a mutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. D else, I perform env create mutable binding, arguments, false. E perform env initialize binding, arguments. O, F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, a let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If his duplicates is true, then I perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else I perform iterator binding initialization of formals with arguments iterator record and env 27. If his parameter expressions is false, then a note, only a single environment record is needed for the parameters and top-level vars. B let instantiated var names be a copy of the list parameter bindings. C for each element n of var names, do I have instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding, n, false. Perform env initialize binding, n, undefined. D let var env be env 28. Else, a note, A separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B let var env be new declarative environment. env. C set the variable environment of callee context to var env. D let instantiated var names be a new empty list. E for each element n of var names. Do I have instantiated var name S does not contain n, then ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding n false if parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined for. Else a let initial value be env get binding value n false. Perform var env initialize binding n initial value. Note: a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note: an xb 3 2 1 adds additional steps at this point. 0. If strict is false, then a let lexi env be new declarative environment. var env be note: non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else a let lexi env be var env. 2. Set the lexical environment of callee context to lexi env. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element D of lex declarations, do a note: a lexically declared name cannot be the same as a function generator declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element Dn of the bound names of D, do I if this constant declaration of D is true, then perform lexi env create a mutable binding. Dn true 2. Else perform lexi env create mutable binding. Dn false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexi env and private env. C perform var env set mutable binding fn fo false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 20, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 103. 1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 103. 2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 103. 1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f, this arguments list, undefined 103, 2, arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in call or construct, f, uninitialized, arguments list, new target 103, 3 built-in call or construct, f, this Arguments list. New target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument, an ECMAScript language value or uninitialized. Arguments list. A list of ECMAScript language values. A new target. A constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized. This value is uninitialized. Otherwise, this argument provides this value. Arguments list provides the named parameters. New target provides the new target value. 1. Note: if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result. 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, comma realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note: when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let fun be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set fun to prototype, set fun to true, set fun to realm, set fun to null. 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0.4 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in table 30. Instead, they have the internal slots listed in table 31, in addition to and table 31, Internal slots of bound function exotic objects. Internal slot. Type. Description. Bound target function. A callable object. The wrapped function object. Bound this. An ECMAScript language value. The value that is always passed as this value when calling the wrapped function. Bound arguments. A list of ECMAScript language values. A list of values whose elements are used as the first arguments to any call to the wrapped function. 186. ECMA International 2024. 1041. 1. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f, let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true, set new target to target. Return. Construct, target, args, new target, 0, 4, 1, 3. Bound function create, target function, bound this, bound args. The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMAScript language value, and bound args, a list of ECMAScript language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function, let internal slots list be the list concatenation of, and the internal slots listed in table 31. Let obj be make basic object, internal slots list. Set obj to proto, set obj as described in 104111. If this constructor, target function, is true, then a set obj as described in 104112. Set obj to target function, set obj to bound this, set obj to bound args 0, return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys, C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every own property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desk. The internal method of an array exotic object takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return. Array set length, a, desk. Else if p is an array index, then a let length desk be ordinary get own property, a, length. B assert, is data descriptor, length desk, is true. C assert, length desk is false. D let length be length desk. E assert, length is a non-negative integral number. F let index be 32. P, G if index length and length desk is false, return false. H let succeeded B. Ordinary define own property, A, P, desk. I have succeeded is false. Return false. J if index length. Then I set length desk to index plus 1, 2. Set succeeded to ordinary define known property a length desk 3. Assert succeeded is true. K return true. Return ordinary define known property a p desk 0 4 2 to array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform ordinary define known property a length property descriptor length true false false. Return a 0 4 2 3 array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If is array is false, return array create length. Let C be get original array constructor. If is constructor C is true, then 88 ECMA International 2024. Let this realm be the current realm record. B let realm be get function realm C. See if this realm and realm are not the same realm record. Then I have same value C realm is true. Set C to undefined. If C is an object, then I set C to get C at species. B if C is null, set C to undefined. If C is undefined, return array create length. If is constructor C is false, throw a type error exception. Return construct C length 0 4 2 4 array set length a desk. The abstract operation array set length takes arguments a an array and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return ordinary define known property a length desk. Let new len desk be a copy of desk. Let new len be to 32 desk. Let number len be to number desk. If same value 0, new len number len is false, throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property a length. Assert is data descriptor. Old len desk is true. Assert old len desk is false 0. Let old len be old len desk 1. If new len old len, then a return ordinary define known property a length new len desk 2. If old len desk is false, return false 3. If new len desk does not have a field or new len desk is true, then a let new writable be true 4. Else a note setting the attribute to false is deferred in case any elim NTS cannot be deleted. B let new writable be false. C set new len desk to true 5. Let succeeded be ordinary define known property a length new len desk 6. If succeeded is false, return false 7. For each own property key P of a such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded be a P B if delete succeeded is false, then I set new len desk to 32 P plus 1 2. If new writable is false, set new len desk to false 3. Perform ordinary define known property a length new len desk 5. Return false 8. If new writable is false, then assert succeeded to ordinary define known property a length property descriptor false. B assert succeeded is true 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desc is an object, then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1, 0, 4, 3, 1. P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desc be ordinary get own property, S, P. If desc is not undefined, return desc. Return string get own property, S, P. 0, 4, 3, 2, P. Desc. The internal method of a string exotic object S takes arguments P, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desc be string get own property, S, P. If string desc is not undefined, then a let extensible be S. P return is compatible property descriptor, extensible, desc, string desc, return. Ordinary define own property, S, P, desc, 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O, assert. Str is a string. Let len be the length of str for each integer I such that 0 len, in ascending order, do a append to string I to keys for each own property key P of O such that P is an array index and to an integer or infinity, P, len, in ascending numeric index order, do a append P to keys for each own property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do a append P to keys. 90. ECMA International 2024 8. For each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do a append P to keys 9. Return keys 0, 4, 3, 4 string create. Value. Prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1, 0, 4, 3, 1. Set S as specified in 1, 0, 4, 3, 2. Set S as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length. Property descriptor, length. False. Enumerable. False. False. Return S, 0, 4, 3, 5. String get own property, S, P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string, P. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be S. Assert. Str is a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r, index plus 1, 1. Return the property descriptor, result str, false, true, false, 0, 4, 4 arguments exotic object S. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMAScript function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed in create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 201336 to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the arguments object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note 4. Ordinary arguments objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMAScript implementations. Note 5. ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, the specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor 0441p. The internal method of an arguments exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property args p. If desk is undefined, return undefined. Let map be args. Let is mapped be has own property map p. If is mapped is true, then a set desk to get map p6 return desk 0442 p desk. The internal method of an arguments exotic object args takes argument p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args. Let is mapped be has own property map p. Let new arg desk be desk. If is mapped is true and is data descriptor desk is true, then if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk 2. Set new arg desk to get map p. Let allowed be ordinary define own property args p. New arg desk 92. ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor desk is true, then I perform map p. Be else if desk has a field, then assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set map p desk false 2. If desk has a field and desk is false, then perform map p8 return true 0443. The let map be args. Let is mapped be has own property map p. If is mapped is false, then a return. Ordinary get, args, p, receiver 4. Else a assert. Map contains a formal parameter mapping for p. B return. Get, map, p 0, 4, 4, 4. The, if same value, args, receiver, is false. Then a let is mapped be false. Else a let map be args, b let is mapped be. Has own property, map, p if is mapped is true. Then a assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable. B perform. Set, map, p, v, false, return. Ordinary set, args, p, v, receiver 0, 4, 4, 5, p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map, p, let result be. Ordinary delete, args, p, if result is true and is mapped is true, then a perform map, p5. Return result, ECMA International 2024 193, 10, 4, 4, 6 create and mapped arguments object. Arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create. %object prototype %set obj to undefined. Perform. Define property or throw. Obj length. Property descriptor len. True enumerable. False. True. Let index be 0. Repeat. While index len a let val be arguments list. Index b perform. Create data property or throw. Obj. To string index val c set index to index plus 1. Perform. Define property or throw. Obj at iterator. Property descriptor. Array prototype values true. False. True. Perform. Define property or throw. Obj callee. Property descriptor. Throw type error false. False. Return obj 0, 4, 4, 7 create mapped arguments object. Func. Formals. Arguments list. env. The abstract operation create mapped arguments object takes arguments func, an object. Formals. A parse node. Arguments list. A list of ECMAScript language values. And env. An environment record. And returns an argument's exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 10, 4, 4, 1. Set obj is specified in 10, 4, 4, 2. Set obj is specified in 10, 4, 4, 5. Set obj to %object prototype %0. Let map be ordinary object create. Null 1. Set obj to map 2. Let parameter names be t he bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0, 5. Repeat. While index len a let val be arguments list. Index b perform. Create data property or throw. Obj. To string index val c set index to index plus 1 6. Perform. Define property or throw. Obj length. Property descriptor len. True. False. True 7. Let map names be a new empty list 8. Set index to number of parameters 1 9. Repeat. While index 0 94. ECMA International 2024 A B C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names 2. If index len, then let g be make arg getter name env. Let p be make arg setter name env. Perform map to string index property descriptor get g false true set index to index 1 20. Perform. Define property or throw. Obj at iterator. Property descriptor. Array prototype values true. False. True 1. Perform. Define property or throw. Obj callee. Property descriptor func, true, false, true 2. Return obj 0, 4, 4, 7, 1 make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0. Note, getter is never directly accessible to ECMAScript code. Return getter, 0, 4, 4, 7, 2 make arg setter, name, env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let setter be create built-in function, setClosure, 1. Note, setter is never directly accessible to ECMAScript code. Return setter, 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string, P be if numeric index is not undefined, then I let value be typed array get element, numeric index 2. If value is undefined, return undefined 3. Return the property descriptor, value, true, true, true. Return ordinary get own property, O, P. ECMA International 2024 195 10, 4, 5, 2. P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string, P be if numeric index is not undefined, return as valid integer index, O, numeric index. Return ordinary has property, O, P 0, 4, 5, 3, P, desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string, P be if numeric index is not undefined, then if as valid integer index, O, numeric index, is false, return false 2. If desk has a field and desk is false, return false 3. If desk has an field and desk is false, return false 5. If as accessor descriptor, desk, is true, return false V. If desk has a field and desk is false, return false V. If desk has a field, perform. Typed array set element, O, numeric int x, desk 7. Return true, return. Ordinary define own property, O, P, desk 0, 4, 5, 4. The. If P is a string, then a let numeric index be canonical numeric index string, P be if numeric index is not undefined, then I return typed array get element, O, numeric index 2. Return ordinary get, O, P, receiver set, P, V, receiver the. If P is a string, then a let numeric index be canonical numeric index string, P be if numeric index is not undefined, then I have same value, O, receiver, is true, then perform. Typed array set element, O, numeric int x, V, return true 2. If as valid integer index, O, numeric int x, is false, return true. Return ordinary set, O, P, V, receiver, 96, ECMA International 2024, 10456, P, the internal method of a typed array. O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string, P, B. If numeric index is not undefined, then if is valid integer index. O, numeric int x, is false, return true, else return false 2. Return. Ordinary delete. O, P, 0, 4, 5, 7. The internal method of a typed array. O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, A, Y, capital W, I, T, H, capital B, U, F, E, R, capital W, I, T, N, E, S, O, sexy ST. Let keys be a new empty list. If this typed array out of bounds, tar record, is false, then a let length be typed array length, tar record be for each integer I such that 0 length, in ascending order, do I append to string I to keys. For each own property key P of O such that P is a string and P is not an integer index, in ascending chronological order of property creation, do I append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do I append P to keys 6. Return keys 0, 4.
I wanted to like
Records and typed array with buffer witness record is a record value used to encapsulate a typed array along.
I wanted to like load up a 64-bit register, but it has to be like backwards, like double backwards. So I gotta like rotate everything to the right because you can't just load to the end of the register. It's really confusing. So I'm not going to do that technique. I'm not even going to use xlat. Something is off. I think it's with the addressing, which is why I want to print it. So I don't know. Or it's just not rebuilding or something. Every now and then the timestamp doesn't change on the file when I hit build or link or whatever. So I don't know. I think I'm done for now. I'll try to like finish up tomorrow. This is getting really boring at this point. I don't have the energy to like adjust this macro that didn't work. I think it was this one. I don't know. I don't have the energy, whatever, to adjust that macro. And dealing with like trying to load up a register when like you can't just set to the end of it because you always have to set to the low part, and like flipping everything around. It's just really annoying. So, and I don't know, something's up. It's not refreshing every time. So I am done for now. Pick it up, whatever, later. My attention span is completely gone. I don't know. I'll let the stream run on for like 10 more minutes or whatever. So it's this whole stream. Nothing really got done at this point. Or like today, whatever. I don't know. Peace.
4, 5.
I don't know. I'm letting the stream run on. I'm not gonna be back. Just sending 10 more minutes. Because like last couple minutes don't always send. This way, they'll probably send. Most likely. Who knows? It's modern software.
Prototype 1. Return A.
So it might not send. 10 minutes. Should be enough though.
The abstract operation typed array byte length takes argument tar record a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O, return length element size 0, 4, 5, 1, 2 typed array length, tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert is typed array out of bounds, tar record is false. Let O be tar record. If O is not auto, return O. Assert is fixed length array buffer, O is false. Let byte offset be O. Let element size be typed array element size, O. Let byte length be tar record. Assert byte length is not detached. Return floor, byte length, byte offset, element size 0, 4, 5, 1, 3 is typed array out of bounds, tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. NGTH 98. ECMA International 2024. 3. Assert is detached buffer. O is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else a let element size be typed array element size. O be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1, 4 is valid integer index. O. Index. The abstract operation is valid integer index takes arguments so, a typed array, and an x, a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, int x, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, A, Y, capital W, I, T, H, capital B, U, F, E, R, capital W, I, T, N, E, S, O, unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If this typed array out of bounds, tar record, is true, return false. Let length be typed array length, tar record. If R, int x, 0 or R, int x, length, return false. Return true. 0, 4, 5, 1, 5 typed array get element. O, index. The abstract operation typed array get element takes argument so, a typed array, and int x, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If as valid integer index, O, int x, is false, return undefined. Let offset be O. Let element size be typed array element size. O. Let byte index in buffer be R, int x, element size plus offset. Let element type be typed array element type. O. Return get value from buffer. O. Byte index in buffer, element type, true, unordered. 0, 4, 5, 1, 6 typed array set element. O, int x, value. The abstract operation typed array set element takes argument so, a typed array, int x, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be to bigint, value. Otherwise, let num value be to number, value. If as valid integer index, O, int x, is true, then a let offset be O, be let element size be typed array element size. O, see let byte index in buffer be R, int x, element size plus offset. D let element type be typed array element type. O, E perform set value in buffer. O, byte index in buffer, element type, num value, true, unordered, return unused. ECMA International 2024 199 104 517 is array buffer view out of bounds. O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record B, capital M, A, K, E, capital D, A, T, A, capital V, I, E, W, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, O, sexy S, T, B return is view out of bounds, view record. Let tar record be, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexy S, T, return is typed array out of bounds, tar record 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module, C16, 2, 3. There is a one-to-one correspondence between the string key down properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string value down property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare FN 10461. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00. ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer 10462. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O V 0 4 6